I hope all the centers are connected and they can hear us. एक बार कर लिए centers को देखें. Chandigarh University. Yes. Who's the coordinator here? Professor Chopra is there. The coordinator is there for Chandigarh University.
Yes, ma'am. It's here.
Okay. Ma'am, you can hear us well?
Perfect.
Okay. All right. Thank you. Let's see. Maharaja Agrasen Institute. Good morning.
Good morning, ma'am.
Good morning. You can hear us well? The
Yes, ma'am. Yes.
Here?
Yes, ma'am. Yes.
All right. Thank you. Thank you. Let's see, Maulana. Stay connected. Maulana, good morning. All right. Your participants are here. Mr. Ashish. Professor Ashish is here.
Yeah, Ashish.
All right. Okay. You can hear us. Connectivity is okay. All right. Okay. Bikaner is here. Thank you. We'll start a session. Good morning, Bikaner. Dr. Praveen. Dr. Praveen is there. Actually, next let's see. And Sikar is not connected. Okay. I see Baddi. Professor Devinder.
He is coming, ma'am. I am Suman Thakur.
Okay, your participants are there?
Yes, ma'am.
We have only 3 participants from your center?
No, ma'am. 17.
Where are the other participants? We have to start the class.
Ma'am, 10 o'clock.
10 o'clock. That will be late. We have to start the class. All the centers are connected now. Please ask the participants to kindly sit in the class. We'll start the session. Yeah, please. Okay, very good morning then, participants again. Today we'll be discussing about the construction industry specific, since the 1 week ICT is on green buildings and all the various techniques related to green buildings, which can lead to sustainable construction. So basically construction industry, as was discussed on the first day, is playing a very major role in all this carbon emissions and everything. So there is a great need for this industry to actually look at it and what ways can they reduce this, and green buildings are part of this construction industry. So today's first session, the focus will be on how to reduce this carbon footprints of this construction industry. We all have to understand that what we have inherited, we have to inherit the same to our children. That is our moral responsibility. The earth, the air, the land, the water, they're not inheritance from our forefathers, but we have it as a loan from our children. So we have to hand over to them at least as it was handed over to us. That is what Mahatma Gandhi had said long time back. So the importance of environmental sustainability has always long been understood by people. So it has always been there, and we need to understand it, that development should not come at the cost of sustainability. So actually what we want is fresh air, fresh water, and fresh earth for all our children also, so that they can eat well, they can have a healthy life. We really don't want to give them dirty water or land which is all dry, which is of no use for farming. So let us look into some environmental problems that not recently in fact have arisen, which are actually a big threat to the sustainable construction that we talk of. The first issue, all of us are aware of it, is the global warming. So actually if we look at it, the level of carbon dioxide in the atmosphere today is the highest actually, which is more than even what has been in the 750,000 years. Since 1980, more than 22 warmest years have been recorded on this earth. And they are all a direct result of greenhouse gas emissions, which are coming out of all the equipment and all the things that we are using in the buildings and other vehicles and other sources of energy. Over 2,500 of the world's leading scientists are agreeing that the major contributing factor is the greenhouse gases, and it has to be addressed on a very wide scale. So it is actually said that if we continue the way to live the way we are living right now, the kind of demand we have on the Mother Earth, one Earth is not enough for us. We need actually 5 Earths so that we can actually continue with this kind of lifestyle. So we are actually overburdening the resources of the Earth. Little examples of what are the repercussions of global warming. It is not just warming. There are other also side effects, as we call. So this is an example. We can see it is a firestorm, which is through Colorado. That is actually what is showing is increased incidence of wildlife, which is a result of the climate change. So all this climate change that is happening is leading to not only temperature increase, but there are consequences like this also. Now let us talk of the earth. What is happening is the forests are shrinking. At the same time, the deserts, they are expanding. Water tables are falling, which was also highlighted earlier. The soils are eroding because the plantation is being taken off. Temperatures are rising, and the seas, as a result, are becoming hostile. So all these tsunamis, tornadoes, they are becoming very common today, which is again leading to loss of property and life. So we have to really sit back and understand we are doing development at this. We are saying that development is for us, a better lifestyle. But if there is no guarantee for life, then what is this development of use? So natural disasters have increased more than 4 times over the last 40 years. Windstorms more than 5 times. Flooding has increased to almost 6 times. And there are bushfires also, which are almost 10 times now. Let us look at another scenario. So this is a 1,000-year-old forest, which was fallen victim to a chainsaw for a new dam. So there was a new dam which was to be constructed. So that came at a cost of a 1,000-year-old forest. This is another example, a rainforest which has been reduced to a barren land. Now let us talk about all the waters and glaciers, the water bodies. So we all understand 96% of the glaciers, water is in the form of glaciers, but they are also diminishing in size now. By 2030, it is estimated if we keep on going by this pace, 2/3 of the glaciers will perish. Mostly, if we talk of some countries, one of the example is Chinese. 300 million of them are relying on water only for irrigation. Over 1 billion people are already suffering from a shortage of clean drinking water. That is already a big scarcity. When glaciers are gone, there will be no irrigation water for the whole of Asia, it is said. So putting the whole world in a net food deficit, which will be a major catastrophe, since Asian countries are producing a major part of all the food supply for the world. So if there is no water available for irrigation, there will be a food shortage, and again, devastating effects are there for the entire nation. It is not just a problem of Asia then. Let us look at this example. So this is an example of Maldives, which is also called a paradise. So it is almost also getting lost. So this is a very popular vacation spot. So it is threatened now by the rising sea levels. So it is also diminishing in size. This is another example, a massive waterfall from melting pack of ice. So these are the only meltwater on Earth, and undeniable proof of how much swiftly climate changing is advancing. So even the glaciers are melting now. Now let's talk about habitat. We all know ecosystem. The Earth is actually giving house to a lot of species, flora, fauna. So 15% of all the plants, animals are threatened with extinction at this stage. The birds, 12%, reptiles, mammals, amphibians, fish. So everyone is actually now threatened. A lot of species are threatened for extinction. Okay? Humans today have the ability to drive almost 500 million species to extinction, if I talk of these numbers. So all these activities are actually all cause of human activity. So we can say all these activities, they are actually now endangering 500 million species. Again, the global growth at the rate of 3% of per annum, it is producing more ill health than wealth at this time. So we have to really start weighing our options at what we are doing. So each month, it is said that 2,500 tons of toxic e-waste is shipped from the Western world to Nigeria. Okay, so that is the amount of e-toxic waste which is being generated, and we are actually dumping it at one place. Yet another example, a single European consumes 50 tons of our planet's resources every year. So this is just an example to show with the increasing lifestyle that we are, the good lifestyle that we are enjoying, the energy intensive lifestyle we are enjoying, it is coming at a cost. We're using planet resources. So how much more mass expansion of human enterprise can we really afford now? We have to really ask questions. This is another example. So because of the disappearing ice cap, even the polar bears are facing shortage of food and even space to live now. Let's talk of pollution. So since 1990, India's carbon dioxide emissions from cars have increased by almost 88%. The world today has almost 800 million cars. Industries at the same time are also causing air pollution. Pesticides being used for agriculture activities is again a major source of pollution, which is polluting the land. And in turn, with irrigation, we are polluting the water also. This is another example of pollution. This is a waste incineration plant which is surrounding Bangladesh. So we can see the pity condition it is in. This is an example, a lignite power plant which is contaminating the air with its emissions. So you can see the bulk of pollution that is being caused. We can see this is an aerial view which we can make out what is the volume of this pollution being generated here. So this is an example of how water is polluted right now. So water is actually polluted with a lot of filth and trash. Our energy demands are increasing. So this is actually a nighttime view of Los Angeles city. So energy demand is actually unfathomable. This is an example. One of the Canadian province, there was a lot of oil, mining of oil sands there, and this is what is left behind of the land now. So because of a mining activity, this is what we have left. This is of an oil field in California. So that is called to the last drop. So merciless overall exploitation by humans has led to this kind of scenario. Now let's talk of another problem which we are facing, population explosion. So this is the view of the overdeveloped metropole of Mexico City. More than 20 million inhabitants are in this city. This is another megatropolis term which is called, and this is this is New Delhi, over 22 million inhabitants. So we all have to understand we are destroying the human habitat with our own hands, with our own technology, and actually if we understand to no purpose in the long run. So let us talk all these impacts that are happening. So we all understand the term carbon footprint, what exactly it is. So actually it is a measure for measuring the climate change. So it is a climate change metric. So carbon footprint, if I just break it up into two words. So carbon refers to the different greenhouse gases that are contributing to the global warming, and footprint is the impact that that particular thing has. So the best estimate of the full climate change impact of an activity, of an item, it can be for a lifestyle, for a company, for an enterprise, can be for a country, or even the whole world can be done in this way. So let's see where does this concept originate from. So there is a term which is called the ecological footprint, and also a term which is called the life cycle assessment, very commonly known as LCA these days. Let's see what is ecological footprint. So ecological footprint is the measure, we all just understood that footprint is the what impact it has. So it is a measure of the human demand on the Earth's ecosystem. So it is the ecologically what demand are we having. So it is a standardized measure of demand for the natural capital that may be contrasted with the planet's ecological capacity to regenerate. So actually how much resources we are using. So to give those resources, how much capacity the Earth has to regenerate that much of resources. So that can be standardized into terms of some natural capital, which becomes the footprint. So it represents the amount of biological productive land and sea area necessary to supply the resources for that particular human activity, and all the associated waste that will be generated, because that will again be then dumped into Earth. So that will also require space. Okay, so all these numbers when add up, they lead to the ecological footprint of that activity. So using this assessment, it is possible to estimate how much of the Earth, or how many Earth we must say now. How much of Earth we should not say. It is not a fraction of Earth now. It is many times of Earth it would take to support humanity if everybody followed a given lifestyle. Okay, I hope you all understand this term now. So for 2006, a quick example. So humanity's total ecological footprint was estimated at 1.4 planet Earths. So we actually required 1.4 times of Earths to sustain the type of lifestyle the whole humanity was sustaining in 2006, right? So this is another way to understand it. So the ecological footprint, it all comes up to how much energy demand we have, and people are settling, they're using earth, all the kind of materials we are using, timber, paper, all those kind of things, the food and the fiber we are using, that is also coming from the earth. It is being produced from the earth, agriculture, seafood we are using. So all these things, when they compare to, so how we are using all these things, so how fast can the earth then regenerate? This becomes the ecological footprint. Now let's look at the other term, which I said was the origin of carbon footprint. It's called the life cycle assessment. So this is basically nothing but an analysis which is done for the entire life cycle, which is based on the ecological balance. And it is also called a cradle to grave analysis. Cradle, we can all connect it to a baby. When it is born, it starts its journey from a cradle, a cot, and the end of a human journey is up to the grave. So from its inception to its end, that is the cradle to grave analysis. So this is basically nothing, a technique which is used to assess the environmental impact associated with all stages of the product's life. All right. So it will actually encompass then production, when it is produced, when it is then manufactured, then used, then also disposed also finally. So it will be using some of the resources. So everything has to be then. So if we talk of any product, so when the raw material is extracted, it is manufactured, then it is distributed to the places of use. When it is being used, again, some resources are being used, it is being repaired and maintained, then it is final disposed or recycled. Okay, so this is a quick picture to show what we just talked of. So now let's, with the background of these two terms, now let's see what is carbon footprint. It is also called as a carbon dioxide equivalent. So carbon footprint is always calculated as an equivalent of the carbon dioxide using some relevant term, which is sometimes used, most commonly used is a 100-year global warming potential, also called the GWP. So what exactly it is? It is a relative measure of how much heat a greenhouse gas traps in the atmosphere. So that is the global warming potential. Okay. So when it compares the amount of heat trapped by a certain mass of the gas, which is in question, to the amount of heat trapped by a similar mass of carbon dioxide. And this number is always calculated over some period. So it can be a 20-year period, it can be a 100-year, or it can be a 500-year period. So when I say 100-year global warming potential, I'm talking of a 100-year period. So I'm comparing each gas. So equivalent mass of carbon dioxide and equivalent mass or certain mass. So how much heat it will trap. Okay, so it is always expressed as a factor of carbon dioxide. So carbon dioxide has been standardized to 1. So let us understand how it goes. So now if I say a 20-year global warming potential of methane, which is also well known, carbon greenhouse gas is 72. So what it means, if the same mass of methane and carbon dioxide were introduced into the atmosphere, methane will trap 72 times more heat than the carbon dioxide over the same period. So this is how it has to be understood. Okay, so carbon dioxide has been standardized as 1. So others are then given a scale according to their impact. Some of the greenhouse gases, okay, so as they are released into the atmosphere, what happens? What is exactly is this greenhouse effect? So when they are released into the atmosphere, they accumulate and they form a barrier which traps the heat created from the sun and increases the temperature of the earth, which we can see also from the diagram on the right side. So a quick example to give here would be the Kyoto Protocol, which originated at the 3rd conference of the parties to the United Nations Convention on Climate Change in 1997. So they had actually identified 6 major greenhouse gases, which are actually a result of human activity. So one, carbon dioxide, we all know, it is coming majorly from the burning of the fossil fuels. Methane, it is 23 times more harmful. Okay, 23 is the global warming potential. The numbers here quoted are for a 100-year potential. Okay, so methane, it is surprising to, we can see here, it is coming from cattle, landfill sites, when there are leaks from the disused mines and also for fossil fuels. Then another gas is the nitrous oxide. We can see it is almost 300 times potential it has. It is coming from the fertilized soils and from fossil fuels. Then there is sulfur hexafluoride. You can see the potential 22,000 times. It is coming from the leaks of the electrical and electronics industry. Okay, so we have to really understand. The idea of showing this is so that we understand what are the sources, so that we can take some measures. Another, perfluorocarbons. Okay, they are coming again from electronic industries, fire extinguishers. Then HFCs, hydrofluorocarbons. They are a variety of these, and their impact ranges from 12 to even 12,000. So they are coming from mainly our air conditioning systems and LPG storage. Okay, so carbon dioxide equivalent, actually, the greenhouse gases, they can be emitted, we have to understand, through the transport, through land clearance, production activities, from the food consumption, fuels, manufactured goods, materials, roads, building, services. So I think we can relate our everyday activity, whatever we are doing, everything is contributing to carbon dioxide equivalent, that is the carbon footprint. Okay. Now we have to understand, we cannot say that a single activity can be only single greenhouse gas. With any activity, there are a multiple of greenhouse gases that can be associated. Okay. So again, carbon footprint then again has to account for all these gases. So they have to be again brought to a common. That is why the carbon dioxide equivalent was set, so that everything can be added. So 1 plus 72, that can be added because they are all in the terms of carbon dioxide equivalent now. Okay. So that is what it is. So all the gases, whatever are having the impact, have to be added there. Okay, so basically the whole idea of measuring something, I think this was also stressed before also, if we measure something, we know what we are causing, we can actually get a little sensitized about the issue and we can do something about it. Okay, so again, once the size of the footprint is known, some strategy can be devised to actually tackle it. Okay, again, climate change is being increasingly recognized as one of the greatest challenges which humanity is facing today. Now, if I talk of, since now we have highlighted that there is a problem, so our next, the coming session, that will be now concentrated on how to reduce this carbon footprint. Okay, so the main influences on carbon footprints include population, economic output, energy, and carbon intensity of the economy. So I think we'll all agree with this now, since we've seen the examples, where and how it is actually present. So these factors have to be then the main targets so that this can decrease the carbon footprint. So the most effective way to decrease the carbon footprint is to either decrease the amount of energy needed for production or to decrease the dependence on the carbon emitting fuels. So if we try to tackle this at the very origin, these two areas, we can actually work on the reduction of the carbon footprint of any activity. So now let us talk of very specifically of the construction industry. If I talk of this construction industry, so its footprints is majorly coming from all the construction materials that are being used, all the construction activities and processes. They are also using energy. They are emitting carbon dioxide. So they are all involved. Then the lifespan operation of all this, of all the products of this industry, which are the buildings and everything structures, when they are operating during the lifestyle, they are using energy, they are emitting gases. So that also is contributing to the carbon footprint. And again, eventual demolition is contributing to the. Now with what is happening is construction industry right now is accounting for more than 50% of the greenhouse gases. So it has now become a mission critical for this construction industry to look at the ways to minimize its footprint. Okay, so right now its contribution is quite high. So let's look at what are the issues. So there is an overwhelming consensus among all scientists that Earth's climate is changing, and most of the observed increase in temperature is due to human-caused gases. So again, what will happen? All these businesses, if I talk of, is for the entire Earth. What is me alone cannot do anything. We don't have to look at it that way. So what is happening? What will happen is now significantly there is an increased pressure to reduce the contribution to the climate change on each and every enterprise, each and every person. Okay. Now, what is happening is now there will be a greater degree of scrutiny over the carbon footprint of every activity. Everyone now needs to demonstrate environmentally responsible practices to remain competitive in the marketplace. Okay, people are now aware, consumers are now aware of these things. So everyone will actually look at the products, at how much is the carbon footprint of that. So we have to actually demonstrate that we are environmentally responsible. So as such, responding to climate change will be one of the major issues which will affect the businesses over the next decade. So the businesses, again, they cannot keep on operating in the same fashion as before. So in the very near future, all facilities will be required to know and report their carbon footprint as a part of their social responsibility and asset management. Okay, so this is about to come now. Unless people know, they will not do it. Okay, so this is about to come then. Let's look at the regulations. Okay, so there are, of course, in the times to come, there will be even more stringent greenhouse gas emissions policies. Initiatives will be exceeding not only voluntary initiatives. Now they will be, earlier there was all on voluntary basis, that people volunteer to actually reduce their emissions and all. Now it will be more than that. Policy measures are likely to emerge, including carbon taxes. So there might be terms coming like, you're paying income tax, you might have to start paying carbon taxes also, okay, which will penalize the greenhouse gas emitters. Emission trading schemes will be specifically targeting the sectors which are causing maximum pollution. Carbon emission policies will be significantly increasing the cost and reducing the competitiveness, especially if the regulations are not applied evenly around the world. So you can understand, if your carbon footprint is too much, you'll be paying more taxes, things are going to get costlier for you. Okay, so and plus people are aware of it, you will be getting less competitive in the market. So companies that lead the way in proactive emissions. So right now I think now is the time to start reacting also, but still it is never too late for a good thing. So we have to be proactive now. Okay, so proactive emission reductions, companies that will lead this way in anticipation of a new regulatory environment may develop significant competitive edges. Okay? So I think since we all, many of us the world is becoming very materialistic. So if we talk of materialistic terms, this is going to cost us now. We have to understand. Now let's talk of another issue and risk related with this, which is the consumer values. Okay? People's concern regarding the negative impacts of climate change have moved to the forefront of the consciousness. Even media coverage these days is quite good on all these environmental disasters, hurricanes, Katrina, and all those things. They are well covered. So actually, they are actually elevating the sense of urgency for the people to actually understand that the impact is quite high these days. Okay, businesses will now be judged on their environmental track record. Okay, it is not just about track records, financial, kitna turnover, and all those things. Things are going to into even environmental track record. Consumers will vote their wallets by purchasing products and services from companies with clear plans to reduce carbon emissions and well-defined measures to minimize the environmental impact of their activities. Since we are again in this 1 week class, we'll be talking about green materials and everything. So we all should then become sensitized, and when we go for construction, we have to start looking for green alternatives for each and every material or product or activity. So people are going to get now well versed with this thing, so that again companies which are actually going green will have an edge there. Again, let's understand, if we go green, it is not only intangible, all the benefits that we've been talking of, environmental, all those things, consumer forum and all. There are also operational costs which get reduced when we talk of green, because we are reducing the emissions, we are reducing the waste. There is more efficiency that is involved in the processes. So it means lesser energy is going in, lesser cost is incurred, and lesser waste means lesser money for disposing it also. So it is again coming at a good savings for the people also who are actually adopting it. So we have to understand that going green is helping the planet and also generating higher profits for the companies. So let's talk of how to reduce this carbon footprint then. Okay, so technological development can of course help us. Better processes, mechanical engineering can be a great help here. How to have better efficiency in all the processes, all the machinery, heavy machinery that is operating in the site, all the JCBs, all the rollers, cranes. So if there is higher efficiency of all this equipment, again, it will lead to lesser fuel consumption and lesser footprint of that construction activity. Okay, even products have to be managed better, which means there has to be all the type of orders that I'm placing. They should be what is required, so that there is no wastage. There is no delay in all the processes, all the products that are coming to the site, because again, delays lead to So all the people are mobilized there, all the equipment is mobilized there, but construction doesn't start. Again, it is leading to wastage of time, money, and energy. So there has to be a better product management also. Again, there is a concept which is picking up very nicely these days, which is also called the green public or private procurement, GPP. Okay, so actually, what it is it says that you should procure goods, services, and works which have a reduced environmental impact throughout their life cycle. Okay, so again, when you're going for a project, you have to adopt that there will be some specific GPP criteria which will be developed. So you can have actually, when you say you'll be going for a house construction, this is the kind of material to be used for the doors, for the window panels, say. So you can go for a GPP criteria that this has to be the reduced carbon dioxide emission from this product that I will go for. Okay. So again, when you're issuing tenders, so call for products or services which have this criteria in place, so that only people who are having green products, they will apply for the tenders. Okay. Carbon again has to be captured. We have to understand what will be the carbon dioxide emission so that we capture it. Okay. Then again, consumption strategies have to be again formulated, because more the wastage, more is the impact on the earth. We've understood that. Okay. Now next, this industry really needs to focus again is on, after procurement, all the waste that is generated. Waste is also generated. Maximum onus is on to recycle this waste. What happens? 85% of the construction waste, if we actually talk of, is what can be easily recycled and reused. So instead of dumping it in the landfills, land which is already very scarce for people to live in, and we are dumping waste into it, which again pollutes the earth where this landfill is happening, actually land becomes unfit for any kind of other activity. So it is always better to recycle this waste, and especially construction waste is nothing but they are all brick pieces, tile pieces, small reinforcement pieces. So they can all be recycled and reused. Okay. So this becomes a very major opportunity for this industry to reduce their footprint. Okay, so actually we have to understand every of the stakeholder of a construction activity has a role to play in it. Okay, all the contractors, even when we talked of the owners, right? When they are calling for tenders, they have a responsibility to play. Then if I talk of contractors, subcontractors, they all can actually play a good role in reducing their construction waste. So there can always be a waste minimization and management plan. WMM it is called these days with all the corporates. So that can actually be put in place for a construction project. So whenever we do a construction project, we all go for construction management these days. So all these kind of things, the GPP, the WMM, they should become a part of the project now. Okay, so that is what will actually help us. Right. Again, all this recycled content, they can again be reused in the site itself. Okay, it is not only reducing the energy consumed to make the end product. So actually, whenever one product is made, there is a lot of energy going into it. If I say wherever it is extracted from the earth, energy has been used. Whenever it is then the raw product is taken into the factory, energy is being used. When it is being produced, energy is being used. So a lot of energy, which is also called the embodied energy, it has gone into this product. So that embodied energy, if it can be used again and again, it will always lead to better results rather than generating a new product which will involve new energy. Okay. Then compactors used on the site, they can also reduce the need for frequent waste collection, leading to fewer waste collection trucks. Even when the waste is there, compactors should be used. They will actually reduce the volume and a better management of this waste. Okay, so this is all what I was talking of. This is actually what is a construction waste is. And I think all of us will agree here that most of it can be recycled and reused. Okay. Insulation material, nails, electric wiring, rebars, this is what all is there. And again, we have to understand most of the construction waste, it may contain lead, asbestos, or other hazardous substances. So putting it in the earth is anyways not a good idea. So, and mostly another one thing is here, whenever we are making estimates for our tenders, when we do a BOQs, bill of quantities. There is always a 2.5 to 5% extra contingency that is built in by the estimators. Okay, so what is happening there? If we do good engineering, we don't have to really put in this 2.5 to 5% extra. What happens? This comes into the site and it is then wasted. So there should be better process engineering that should be involved there. We should not try to put in too much of factor of safeties into each and everything. Okay. This is basically construction and demolition debris breakdown. So residential construction 6%, non-residential 3%. Then renovation involves most of the debris. When we do renovate, we just throw away old things, 22%. Okay. Then non-residential demolition again. Demolition is again a lot of waste which is generated. We have to understand. So construction is less. Then I go to renovation, more debris, and then final demolition is the maximum debris. So again, the idea is to reuse things, don't just demolish it. Now let's understand construction waste is not just what is generated on the site. The origin can go back to design also. Okay. Even in our design, if you're putting a lot of factor of safeties and all those things, we are unnecessarily producing big beam sizes, big column sizes. So that is again leading to wastage. Okay. So we have to actually start having more confidence in our engineering, so that we should go for better designs and more economical designs at the same time. And of course, we talked about the waste which is generated directly at the site during construction. So uneconomical design solution should now be actually not done. We need to start actually getting into the full, one example again is limit state design. So working stress design, which was the old design that had a lot of factor of safety. So limit state design has started to be more economical, and many countries have adopted it now. And most of the place limit state design is being used now. So that is of course a good thing. It is a more economical design there. So these are again some of the examples. The reason I'm stressing on it is because we can actually understand even when we're doing our own home renovation. Let's not talk about big projects. You can talk of our own houses also when you're doing all these renovations. So we are just actually throwing all these things. Dry lining, which is very commonly used in Western nations also. That is plasterboard sheets, metal studs for wall heights and openings. The floorings, floor tiles, which are almost always cut to fit the room layouts. So we can go for more modular sizes, okay, so that there is less of cutting involved. Ceilings, insulation, tiling, paving. So all these things are actually mostly cut to small sizes, and small pieces are just actually thrown away. Again, inaccurate or surplus ordering of material should not be done. Okay, this is a direct which can be actually taken care of in the WMM that we talked of, waste management. Construction management has to really come into place now. Okay, sometimes handling errors are there that damages the products. Okay, we are not storing it, handling it properly while actually dismounting it from the truck which has come to deliver it. So there might be mishandling that is again leading to wastage of the material. There might be inadequate storage at the site. So that is again leading, say cement bags are just lying there, rain comes and they are all washed off. So we have to actually provide proper storage, which means proper site management has to come into place. Sometimes there is damage which is generated by poor coordination with other trades. Okay, say site there is an electrical person is also working, an HVAC person is also working, the civil engineer is also working, the construction person. So what happens? There is a poor coordination of the store which is actually responsible for providing material to them. So there is less coordination. Maybe there was not a good coordination on when the activity is supposed to complete, or the say slab work, and then the next electrical fittings have to go in. So if there is less coordination, then again there will be wastage of material just lying vacant there on the site and getting damaged. Sometimes what happens due to low quality of work, so it might have to be redone. Again, that is a lot of wastage. Materials are sometimes very inefficiently used. Okay, we see a lot of when cementing, concreting is done, there is a lot of wastage there. Okay, or even all other activities, there's a lot of inefficient use. Okay, again, temporary work materials, they should also be done very efficiently. If I'm talking of all the form work, scaffolding and all, so they are all materials, they are being used. So they should be put in such a way, whatever is required, it is put up. And actually the construction sites, all the big contractors that they are there, they are actually doing a lot of big projects. So they should design it in a way that the formwork can be reused on the other side, unless there is some special requirement of the site. So mostly this formwork should be reused and not wasted. So again, enough stressed, this construction waste, if it is reduced, it has financial benefits. Waste has a cost, okay? Most of it, what we don't understand, we don't look at it. We just think a waste hai, just get rid of this waste, make my house clean, make my site clean. We don't understand that it is coming at a cost to us. Okay. So main contractors should have the responsibility for the waste disposal. Although in most cases, waste is generated by subcontractors. Okay. Clients, main contractors, subcontractors, they now have to start actually focusing on this issue. Mostly what has happened is because even what government and many places they have done on the landfill, they have actually increased the tax there. So now the industries are actually getting to know that to send the waste to the landfill will cost me money now. Okay. Now again, let's talk of, if I talk of subcontractors, subcontractor may say ki I just get my job done, waste, whatever is coming, let it be. No, even the subcontractors have a benefit that they are ensuing here. So reducing the wastage of the material will result in a total saving to the project or increase in the profit of the subcontractor. So later it can actually maintain the tender prices with reduced material cost. So whatever it had quoted, if it is trying to put in, the subcontractor now puts in more efficient ways of maintaining the site. So they will actually end up having some profit over what they had actually tendered for. Okay. So either way, subcontractors stand to benefit from using their materials more efficiently. Okay. So if they can willingly they demonstrate that they want to support and engage in waste reduction measures and demonstrate that these they have an effect on their waste, they can again be seen as a better bidders. Okay, a subcontractor who says I will have less wastage. There is always a contingent. When we do BOQs, we always have a contingencies 5 to 10%, which is straight away put on the total cost of the project. What has been estimated actually engineeringly doing all the calculations. Okay, so if a subcontractor comes and says my contingency part is less, 1 to 2% lesser than what historically has been done, of course he will be a preferred person for the project. So again, it is in the again it is better for the subcontractor to improve its own working so that it can get better projects then. Now again, the benefit is again to the clients and the contractors also. Okay, so this cost, which is again the waste cost of the waste, is actually built in into the project cost. So if this fat can be reduced there, so the cost of the project will come down. Again, whatever is the saving, it will again be shared between all the contractors and the clients only. So it is a win-win situation everywhere. Okay, now let's see. Now there are two important aspects of material efficiency since we're talking of material less wastage. So material efficiency plays a big role. Okay, so one is how you select the product and how you manage the waste. So it can be broken down into two constitutive parts which have an impact on both. If I talk of conserving the natural resources, so recycled packaging and waste results in a reduced demand for virgin materials. If I'm using recycled material, I'm not using what is virgin, which is new, direct from the earth. Okay, so we should actually stress on using recycled products for our construction sites. Okay, so we have to encourage higher levels of recycling. At the same time, this will be minimizing the environmental damage. Reduced waste means less quantity of landfill space used and reduced environmental impact in terms of embodied carbon dioxide, which was associated with extracting, transporting, and manufacturing, which I talked of embodied energy. Okay, so once a product was made, there's a lot of embodied energy it has. Now you put it in the landfill, now that is just waste there. It is not being used now anymore. So try to bring it back to the cycle, let it be used again and again and again. So again, we all have to understand the focus, the actual responsibility of construction waste reduction has to be shared between all the parties of the supply chain, from the client right down to the waste contractor. Even waste contractor can play a big role here. So there has to be a focus on the role of contractors and subcontractors, that they cannot work in isolation. They have to manage their waste. Okay, so everybody has to go towards a common goal and leadership is required here. I talked of, let's talk of very specifically now client's role. So we talked of GPP, the green procurement, private procurement. So that is one concept which is here. So even clients can demonstrate leadership by setting requirements for the efficient use of materials. Okay, a client can say that I have a project. So in my project, I want that there should be an efficient use of material. Only recycled materials should be used. Okay, material with lesser carbon footprint should be used. Okay, again, the communication has to be there between the client and the all the teams which are there on the project. Okay, again, another thing what comes is, if I talk of waste management, first of all, I need to know what are the kind of waste. So there might be small waste, big waste. So all kind of waste should be identified and accounted for when we are doing such kind of planning. Okay. Again, we have to, through the process of management, we have to ensure that all the people who can play a role in it, they actually play a role. So it is a part of effective management then. If I talk of the main contractor, what role they can play? They can deliver the client's requirements by developing a site waste management plan. Okay, there can be a site waste management plan. It should have a very clear estimate and targets of the waste that will be generated. There has to be a very clear strategy to reduce the waste and clear strategy to ensure how the recycling of the residual waste is maximized. Okay, so we have to ensure that recycling is maximized and reduces waste. Waste is reduced at the first place. Okay. Again, the concept of reduce, reuse, and recycle should always be applied. So first of all, try to reduce the amount of material being used, then reuse, and last option is recycle, and nothing can be done. Then it's the final landfill part that should come. Again, the waste data. If I say I am putting a plan in place, site waste management plan, so the waste data has to be actually generated and monitored at all the time. And again, it should come with a cycle of continuous improvement. When we talk of any management, I think most of the friends here would agree, and all the centers also, they would agree that any management is based on the 4 principles of PDCA cycle, which is commonly called as the PDCA cycle, which is plan, do, check, act. So that is a very common thing which is used for all the management cycles. So if I would say this is the same cycle, it is a management process if I'm talking of site waste management. So the same principle has to be applied to this management also, site waste management. And a PDCA cycle is always characterized by a circle of continuous improvement at all the times. At each and every step of the PDCA cycle, there should be a continual improvement that should happen with the system. Okay, it should not be that once you have planned it, okay, done and forget it. There should always be improvement. You have to plan it, you have to implement it, keep on checking it if it is going well or not. There are problems, act on it, take some corrective actions. Then you reach a level of improvement, you perform there. Again, you should rise to the next step of improvement there. Okay. So again, applying that same principle to the site waste management. Okay. So again, waste data has to be collected. If I put something in place, data has to be collected, then it has to be monitored. It will be compared with what estimates I had made when I had done my planning. I had planned that, say, this X tons of waste will be produced from this site. Now I get the actual data after implementing that plan. Now the target has been achieved or not. We have to do that. Okay. Again, with these kind of things, so all the subcontractors' data should also be included in this based on actual waste performance. Now let's talk of the subcontractors' role. Okay, so they have what their task is, of course, is to produce the accurate waste estimates of their trade. Okay, you should not look at it, okay, if I show that I'm producing so much of waste, it will go against me. We should always look at it as a process of improvement. If I have the actual data, I can act on it, and it can actually be a learning cycle for the other projects also. Okay. Again, subcontractor can develop actions to reduce the waste and supply this information to the main contractor. All this has to be, of course, recorded in the site waste management plan, which has been made. Okay. Radically, it will affect the performance of the site. Okay. Just in delivery time strategy has to be done. Okay. In-time delivery, of course, is required at the same time. So using materials in an efficient manner during construction and wherever possible ensures that waste is minimized, and on completion, accurate data should be provided to the final team which is monitoring it. Again, whenever we talk of new concepts, we always say best practices are there, and it is always good to share these best practices. So we also have to, we have to say here is we should actually develop a best practice approach even to the waste reduction. Okay. So wherever possible, wherever even small or big step, just try to identify where even the design team can identify where the reduce can be waste. Okay. Site waste management plan, of course, has to be put by the contractor, and the main contractors have to estimate, reduce, and report their waste performance. Okay. Again, the same cycle that I talked of. So this will of course follow again that same cycle: planning, implementation, then reviewing it, and then improving it. Okay. Now, sometimes even the waste targets are set by the clients. Okay, so there has to be a proper estimate. When I'm planning, I have to put an estimate that this will be the waste that is generated, and my target is that through this product, I will reduce the waste to this much. Okay. Now, planning should also tell what will be the action to reduce the waste. Just setting the targets is not enough. We have to tell how we will achieve it. Okay. And again, there has to be proper actions to see that the waste is not going to the landfill. Okay. Implementation actually directly relates to the construction phase of the project, when actually the project is being implemented. So actually practical measures that will all and they have to be now implemented. Okay, they have to be implemented, and they must ensure that the solutions proposed are put into action and effectively monitored at the same time. And at the same time, proper authority and responsibility have to be given to the people who are responsible for actually implementing this plan, and we have to provide them the proper resources also. Unless there is responsibility, there is accountability, the job is not really done. That is a very basic principle of management. So authority has to be given, and at the same time, responsibility, accountability has to be there for the people to be answerable for the task they are assigned. Again, as I said before also, lessons are to be learned from each project, and they should all go into the planning of the next project for that contractor. Okay, apart from whatever we have talked of, many of these points already. Again, storage was already discussed. Now, again, there is also, we can also consider doing some off-site manufacturing or construction. So that will actually reduce the waste, because at the site, the quality control is of course not as good as you can do it in a controlled manner if you do it in a fabrication shop or something like that. So that is one way. Prefabricated buildings are actually, prefabricated elements are being used these days, and they are actually a very good solution to sustainable construction. So prefabricated and all those offsite manufacturing, they will have better quality control, lesser wastage if they're done in a more factory type of conditions. Okay. Even packaging, if I talk of material which is coming in the packaging, okay, what we do is that is nothing but cardboards and all. So tiles, they are coming in boxes. If I take a simple example of a tile box, okay, we are just throwing that box. So if I say as a contractor today, I have put a target that I have to, with this project, I have to reduce the waste to almost 10% by 10%. So I can actually go for some reusable packaging. Okay, after taking out the tiles, I can actually send back these packages back to the supplier. He can use it again. So I can put this as a part of when I put tender. So whoever bids for the supplier, I have to put in this clause that I want reusable packaging. So that will again the supplier will ensure that he's giving you the reusable packaging, and you have reduced the carbon dioxide footprint of your site. So this is one small example which can be done. Okay. Now again, there can be all the rules. You can give people all the resources. You can put all kinds of rules and regulations on them. But if there is no attitude to follow it, it will not be followed. So people have to be trained and educated on the need for this and how they have to accomplish this. So attitude always has to be there. So people should be trained. They should be educated on how they can contribute to this thing. And actually, when we talk of a management plan, so people, all those who are involved, they have to be told what their role is so that they can actually accomplish that, and they should understand what is their importance in this cycle. Again, contractors can also go for incentives. People who are actually taking special measures, they are doing some innovations in reducing waste, they can be given some incentives. Good practices should be shared among people. It always generates good vibes. Sometimes it was always said that ये सब कहने की बातें होती है. It is not really practical to put it in place and all. So if good practices are shared, people will also get some good signals that yes, people are doing it. Why not? I can do it. Okay. And when they see actually the numbers that this was the amount of waste that was reduced, this was my financial benefits. So of course it will be a good motivation for other peoples also. Okay. Again, there are a lot of training tools which are there. There are toolbox talks that are there. So a lot of people are doing these days. So all the contractors, they can have some, we do WhatsApp these days. We're also fond of WhatsApp. Why don't we start doing WhatsApp or these things? Okay, people can have WhatsApp group. They can share what they have done to reduce their waste on the site. Contractors can have it. They can be toolboxes, talks, and all those kind of things. So social media is there. So we can always, rather than just sending good morning, good evening messages, we can at least start at least sharing some good practices amongst ourselves. Okay. Again, we have to understand communication is always the key to the success of any management plan. So there has to be good communication, two-way communication always. So more interaction has to be there between estimators, buyers, site managers, and operators. Okay. If a client has set a target for itself, so it has to, of course, convey it to the person who will be executing it. Then only it will get executed. Okay? So there has to be proper interaction, not only communication, interaction. Okay. So they should be interacting. Now, when I talk of review, okay. So again, after the site is done, we're done with the work. We should actually review what was our waste with this project, okay, so that we can report those numbers. Again, if I'm reviewing it, I can actually understand that I had planned it this way, so I can learn that okay, this will work and this cannot work in this type of scenario. Okay, we can do our own learnings here. Improvement, of course, has to be there. So a company can demonstrate best practice, they can improve their performance. Company-wide commitment has to be there to waste minimization and management for an improved reputation with the clients. People do look at these things. A lot of companies these days, they are very sensitized towards the CSR, that is the corporate social responsibility. So a lot of people these days, they are looking at it. The main benefit of improving performance in waste minimization is the ability to deliver the projects at a lower cost. Again, the same thing is there. Okay. Again, innovations have to be promoted. You can give some incentives. You can have some contest in your sites or something like that. So all these things can be there. Okay. Lessons learned have to be shared. Again, one important slide, I would say, reduce. When I talk of all this sustainability, so reduce is something which will have the maximum impact, then is reuse, and then is recycle. Okay, so reduce the waste by buying goods more efficiently, reuse unwanted items wherever possible instead of disposing them, and recycle or compost what cannot be reused. Okay, then whatever is left, that should be sent to the landfill. Okay, now after we have talked of all the waste minimization at the site, another thing that construction industry can do to reduce the carbon footprint is the water consumption reduction. Okay, so water consumption reduction will also go a long way. Okay, mostly water in many cases is obtained through desalination, a huge energy consuming process, we all understand. So potable water use can be reduced through the use of low water using plumbing fixtures. Okay, whatever sites you are developing, so put in low water using plumbing fixtures, efficient landscape irrigation system, recycle grey water systems. Okay, recycling tanks can be there. So to reduce the water consumption of the building that is being developed. So that will also actually add to the construction industry only. Okay, these days when we talk of sustainability, there are 3 zeros which are very common. Zero carbon, okay, which means no carbon dioxide emissions, zero carbon, zero water, in terms of water wastage, no wastage, and zero waste, okay, or other waste also, solid waste and other waste. So these 3 zeros should always be the target of any construction project. Now again, the choice of material will also help in reducing the carbon footprint. Okay, so whatever the facade of the building that you are choosing, I think that was enough stressed on first day. That will actually determine what will be the energy consumption of the building. So a glass building or what kind of thermal mass you want to put in, that will actually lead to what kind of energy consumption will be there. So all these decisions are actually made at the time of construction. So this is a part of that, okay. I will not actually stress on this. This was already discussed on the first day. Okay, geosystems are there. Okay, there are a lot of things are coming up these days apart from glass, high performance glass and everything. Geosystems, so retaining walls, steepened slopes, drainage. They are there for improvement of soft ground, existing slopes, as well as for the construction of earthwork and roads. They actually, geosystems lead to reduced volumes of excavation. There is a reduced footprint of the ground engineering. There is reduced material wastage by introduction of an engineering geocomponent. Okay. Reduced consumption of higher grade construction aggregates is there. If you use a geocomponent, geo is nothing but earth. So if you're using an earth related component, there is always lesser of it. Reduced construction haulage from lower volumes of material import. It is of course lesser sizes also. And reduced usage of high embodied carbon materials like steel or other aggregates. Okay. Now another aspect of it, if I look at steel. Steel is one of the most recyclable material. Okay, how many times you can use it, recycle it, and then again reuse it with the same strength and quality. So it is a very strong material also. So you can build light structures, stable structures, and lesser material used. Okay, it is easy to work with. It doesn't take time to dry. It saves a lot of time on the site. So they can also be looked at as a good material for construction. Now another, since that transportation of material is adding to the carbon footprint, so try to use local materials so that there is lesser transportation involved. Okay. And of course, a material which is local to that site will jive well with that site and perform better. It will have lower impact on that site. Try to use natural materials again, more natural, lesser the toxic things which are coming out of it. So stone, wood, they are all there. But again, they have to be judiciously used. Natural materials such as stone and wood, they take less energy to manufacture than steel and aluminium. So all these judicious decisions have to be taken. So these are all the options that are available. Okay. Again, one thing we can always, when we're making buildings, we can put a vegetated roof on a top. That will also reduce the carbon footprint of that building. Okay. This filters the air pollutants deposited from the atmosphere, and it also stores carbon dioxide. Earth covered building. Okay. Very ancient techniques, and still popular, and they can still be used in today's days. We have forgotten those things, but they are all very good. Okay, so and even I think in the Gujarat earthquakes, it was actually seen that these old buildings, they performed much better than the newly constructed buildings. So this was also discussed, I think, previously also during this course, that earth covered buildings, they have a much better indoor environment quality. Okay, talking of natural products again, this is one example for a wood. If wood is not destroyed, the carbon that was fixed by photosynthesis can act as a long-term carbon store. Okay, so this means that wood has a negative carbon footprint. Okay, but again, wood has to be used judiciously. So the idea is we're talking of carbon footprint is the amount of carbon dioxide released. Okay, now wood is coming from the plants, and plants are not releasers but actually storers of carbon dioxide. Okay. So actually wood-based products such as paper, board packaging can also act as short-term carbon stores. But again, they have to be used judiciously, not leading to any reckless deforestation. Okay. So the emissions associated with harvesting, transporting and processing of wood products are smaller compared to other products. Okay. Again, cement, I think cement, 1 ton of cement actually emits 1 ton of carbon dioxide also. So, but there is a lot of innovations that is happening these days in cement. This was also discussed in the first lecture. So consume less concrete for new structures, consume less cement in concrete mixtures. Okay. So cement is being replaced by a lot of other binders these days, fly ash and a lot of other things are there, binders are there. Okay. Alcophene and all those kind of things. A lot of things are coming now. Okay. Even now in cementing material, less clinker should be used then. Okay. Clinker is the main source which is actually emitting the carbon dioxide. When whatever is the reaction of the cement going to concrete, how carbon dioxide is emitted. Again, there can be innovative architectural concepts and structural designs. Okay, so use of composite beams can be actually promoted. So lesser use of concrete is there. Then go for composite beams. Go for a mix of masonry, concrete or steel, concrete, all those kind of things. Okay. Again, when we talk of sustainability, making durable structures is also part of it. Okay. Durable structure means it will require lesser amount of maintenance, lesser amount of renovations. So lesser renovations, lesser use of materials and all those things. So it will again lead to savings. So durability should also be kept into mind. So whenever if you're building it once, build a durable structure. Okay. We did discuss this. Precast, these days, precast is building up fast. So precast columns and beams, they are detailed for easy assembly, disassembly, and reassembly form prefabricated buildings. Okay. Again, there are a lot of chemical admixtures that are available, which are reducing the water cement ratio and all those kind of things, and even giving higher strength at lesser days and all those kind of things. So all these things will go along with actually reducing the impact of the concrete construction. Okay. Again, already stressed a lot. So project management has to be in place. Okay, not only for waste reduction, waste minimization, but also for the all aspects of the project. So that everywhere there is good coordination, and sustainability has to be built in all the cycles of the project, right from the inception to the planning up to the handing over to the company, and then again of its use also. Okay, so whatever sustainability standards and all have been developed, we say when we develop a green building, okay, so that green building, it has to be also, it is constructed in a green way, but again it has to be used also in a green way. If it is not used in a green way, the whole purpose is defeated, because construction is only a very small part of the life cycle of that building. The major cycle is always the use of the building. It has to be used in the green way also. So even the guidelines of contractor who has developed a green building, they should also develop some guidelines on how to use this green building, and those guidelines should then be transferred to the users of the green building so that they can continue using the building in a green way. Okay. Again, all your energy, we talked of the 5 components. So energy efficiency, that has to be monitored so that we know where we are going. Okay. Site location, that was already discussed for our construction sites. Okay, go for a good site location. I will not go into these things, already discussed. So if we talk of a carbon footprint of a building, okay, this carbon footprint of any building is coming from the emissions from the energy used in the building. Also the emissions from the transportation to and fro to the building. Okay, people who are coming and going every day to use that building. Energy emissions from the energy used for providing water to that building. That is also the carbon footprint of that building. And of course, related to the construction of the building. So you can see there is a lot of things that are involved in the carbon footprint. Okay, so if we talk of the construction activities and construction materials, that is only 80%, 20% of the embodied carbon emissions. 80% is what comes during the operation part of the building. That is through all the heating, electrical consumption of the building during its lifespan. Okay, so again, we have to understand operation is very important. So if we are actually looking at energy efficiency for that 80% of the part, that will play a big role. Okay, this is a small slide showing how much are the carbon dioxide emissions per household per year. Okay, so space heating is taking a lot of in cold spaces where it is done. Air conditioning is there, water heating, refrigerator, freezers, cooking, appliances, lighting. So they are all actually contributing to this carbon dioxide emissions. So energy efficiency has to be there. Okay, just to sum it up, I think it has already been discussed. Building envelope can play a big role on how much is the heat cooling demand if you're located in a hot place. So all your electrical or mechanical devices, they can play a big role. Okay, regulated process load should be there, radiant heating and cooling, occupancy sensors. Based on that, the ACs can be operated, however much is the occupancy. Okay, use of conservatory should be there, backups should be there, insulating wrap around water heating storage tanks, and occupant behavior modification. Again, attitude of the people matters. Okay, I can provide all solar energy, all renewable energy on my site, but if that energy is being wasted, that is not a good idea. Okay, if people are not switching off the lights produced from the solar energy, then purpose is again defeated. Okay, building orientation, okay, that can play a big role. So at the construction, at the time of construction, we have to take care of this. That will give you a good daylighting, good natural ventilation. Water conservation, again, we'll be discussing this in the next session also. Low flow faucets and shower heads, waterless urinals also shown, storage, grey water recycling, evaporative cooling, all those courtyard systems and all that was discussed, all the systems they were having ponds and water bodies within the building, that was, those examples were shown on the first day. Okay, building management systems, okay, that is one thing I would like to stress here. Again, just as I said, I can manage anything, right? So even building can be managed. So there should be a building management system. It is very commonly called as BMS, building management system. There are actually companies which are providing services for that. They actually manage how the building is managed. If there is centralized heating, cooling, all those heating and cooling demands, everything is actually managed. Okay. Permaculture, sustainability, plant trees. Okay. So again, there are a lot of agencies. This was already told: LEED, USGCBC, and IGBC is there, GRIHA is there. Okay. So we have to understand whether we are an owner, contractor, or an architect. We have to design and construct buildings that require far less energy to operate than the typical buildings that have been constructed in the past. So our target has now to be whatever has been constructed in the past. The new building should, of course, require less energy to operate. Okay. Again, this is one example. Windows. When we talk of Windows, okay, Windows. Already this has been discussed yesterday. Just stressing it again. So they are one place where the heat will come or go. So you have to be very careful about it. Try to, when you're going for renovating, try to use the older windows again, because again it has embodied energy into it. Okay, insulation should be done proper. Okay, so there are no wind leaks and all those kind of things. Okay, so preservation is sustainability. The greenest building is the one which was already built. We have to understand that. Okay, just demolishing an existing structure and making a new building instead of it is never more green than actually preserving and reusing that building which is already there. Okay, that has a lot of embodied energy into it. Okay. So regular repair and maintenance should be done so that things can go more durable. They can behave more durably. Okay. Now, again, if I talk of reducing carbon footprint, okay, we should not rely on just one form of technology. We have to have a green solutions. Okay. We should not work on for a construction site. Don't try to take any site which is a home to any endangered plant or animal species. Okay. Should not send any construction waste to the landfills. We should not forget that there is a microclimate of that site, and that should not be tampered with. Okay. So there should be shading devices and all should be there. I think heat island effect was discussed in the first day. Okay. Green building is not expensive. You have to understand sustainable buildings are less costly to operate and maintain. And these days, with all the research and all going on the green products and technologies, so even the incremental cost of constructing this green building has gone down very less, and even the payback period is coming down to almost 2 years or something like that. Okay. Okay. Now, one thing, so carbon, to reduce your carbon footprint, there is also something called as carbon offsetting. So if you cannot do it at your site, you can offset at some place. I think this concept was introduced in the first session also. So the mitigation of carbon footprints through the development of alternative projects can be done, such as solar, wind, or radioactive energy or reforestation. Okay. So if you cannot do it at your site, you can invest in some other green project at some other place. Okay, that can also be done. So you're carbon offsetting it. Okay, that is what it is called. Okay, again, passive solar houses, we have to do that. Okay, solar houses, passive solar houses, they are the simplest, which is what I think the first day architect Bagga had talked about. They were all passive solar houses. They were active solar is when they're actively using the solar devices. Passive solar is when they're using the sunlight and all in a passive way, not through active mechanical devices. Okay? So a passive solar house, which is becoming its own collector, storer, and distributor of solar heat. Okay. Well, that has all been discussed. Okay. You can always go for hybrid also. Do a hybrid of this. Okay. Now, another term which we must understand since we are discussing this, okay, is called as carbon neutrality. Okay, which means a carbon footprint of 0. Okay, buildings and activities that result in a net quantity of carbon emissions equal to 0. Okay, so a net. Please understand it is a net number. Okay, if there is a plus somewhere, there can be a minus somewhere else, so the net becomes 0. Okay. Okay, again, so carbon offsetting can be done. So most of the times it will not be possible to make everything to 0 from the production side itself. So they can choose to invest at other places. That is called the offsetting. Okay. Again, carbon footprint, if I say I should know how to calculate it, okay, it is essential, but not impossible. Okay. So there are a lot of standards which are there to our aid for this. The ISO, we all use these standards, International Organization of Standardization. They have standards on life cycle analysis. There is ISO 14,000 family actually, that is actually based on all these things. So you can go have a look at those. Just to name a few, ISO 14044 and 40, they are for the life cycle analysis. Okay. So basically, if you have to calculate your carbon footprint, okay, so first of all, you have to establish the boundaries of this assessment of this carbon footprint, okay. So what are the organizational boundary, okay? I have to confine myself to somewhere, okay? I will do the assessment for this particular organization, this operation of that organization, and I will take into account all the greenhouse gases, okay? Then data has to be collected, and then proper emission factors as told has to be put in. So carbon dioxide equivalent for all the gases, then that factor has to be put in, okay? So again, understand assessment boundary when I say, so electrical consumption will be there, some gas and heating oil will be used, that will be there, refrigerant losses will be there will be company owned vehicles, okay, people are using it, people are flying for the projects every day, that is also part of the company's carbon footprint, okay. Business travel, yes, it is there, commuting, waste disposal, all the deliveries by the third parties, that energy used, that is also coming into this building. So all these things have to be identified, okay. I will not go into much details. I think I've given you the gist. So there needs to be proper cognizance. So again, beware, instead of a footprint, don't end up calculating only a toe print, okay. So please account for all the factors. Sometimes we actually overlook some of the major factors, which what happens that instead of 100, we end up calculating 20 or 30. Just to give an example. So don't, this is also a very common term, carbon toe print, okay, which is what happens if properly all the factors are not taken into account, okay. Let me just give you a quick example of it. The two carbon footprint of driving a car includes not only the emissions that is coming out of the exhaust pipe, but also the emissions that take place when oil was extracted, shipped, refined into fuel and transported to the petrol station, not to mention the substantial emissions caused by producing and maintaining the car. Okay, so if I have to do something for a car, so it will not only कि उस वक्त pipe में से कितना निकल रहा है, is all the things that are involved with it. Okay, just to give a little example. Okay. Okay, so I think all the importance is there, of course. So this will, if we reduce the carbon footprint, it will of course lead to the sustainable development. Okay. There are social aspects also involved to it. Okay, there has to be all the knowledge and awareness that should be actually shared. Okay, lifelong buildings should be there. Sustainable urban planning should be done when we're talking of construction industry. Okay, urban planning is a big part in it. Okay, because there is a lot of food shortage, home shortage. So urban planning should be in such a way that people can sustain themselves. Okay. Because one aspect that I would like to, because if there is not proper urban planning, people will start, what happens is sometimes they might start, deforestation happens, they start living near the coast and all those things. Then if any calamity happens, there is a property and damage of life. So that again is not a sustainable thing. Okay. I think we've all discussed this side by side when we were doing our discussion. We've all discussed all this waste management and all these things. Renewable energy should be put into sites. Okay. I think the time is little less. I will stop before the case studies here. So let's see if we have any questions from any of the centers or any comments, anything, any experience you would like to share here. Centers, please. Anyone? Any questions? What is this? Is Chandigarh University? Any questions, Center? This is Chandigarh University.
Good morning, ma'am.
Yes, good morning, please.
Is there any difference between e-waste and solid waste? We have discussed in the first slide, 2,500 of e-waste is transferred from Western countries to Nigeria.
Yes. E-waste is basically, when I talk of e-waste, that is specifically related to all the e-products that we're using, all these laptops, batteries, all those kind of things. Okay, when we talk of solid waste, that is all the waste which is generated, like all the organic matter, inorganic matter, which is coming out of any household or any building. Okay, so that is what is solid waste.
What are e-waste? I mean, any example basically?
E-waste like batteries that you are disposing.
Okay.
They are a big hazard to the land if you actually put it in the landfill. It is a big hazard.
Thank you, madam.
That is electronic waste. E means actually electronic waste.
So basically, these are not disposable. No?
No, it has to be disposed in a very proper manner. There is proper, there are actually agencies which are designated, which have the kind of facilities to first treat this waste and then send it to the landfill. It cannot be disposed as such. It cannot be, you cannot dump it into the land. It requires some treatment before it is put into the land.
Okay, okay. Thank you.
Yeah. Any other center? Any questions? I think we're running out of time also. Yes, this is Maharaja Agrasen. IC Baddi. Any questions? Any comments?
Yes, ma'am. One question is about waste material, ma'am.
Yes, please.
Ma'am, there are two materials present in nature. One is biodegradable and non-biodegradable.
Okay.
Biodegradable materials already exist in nature, but non-biodegradable materials are not existing. But one method is one that we can only reuse it. But have any other method we can completely vanish it?
I don't understand. The one with non-biodegradable. First, again, the idea is try to don't make it a waste. Try to recycle it, reuse it.
Ma'am, two materials are present in nature. One is biodegradable and non-biodegradable.
Right.
Biodegradable materials already exist in nature.
Yes. So actually, if you put them in the earth, they will degrade themselves and become a part of the earth. Yes. And non-biodegradable, they will not degrade themselves. Yes.
Ma'am, non-biodegradable materials only can exist it, only we can reuse it. But have any other method we can completely vanish it?
Completely vanish it.
See, ma'am, have any other method, ma'am?
See, again, what I would say is these are all a part of our production processes and all that. See, a good example would be all the plastics, okay? So in earlier days, world was functioning without plastics. For our needs, we made plastics, okay? Of course, it has all plus minuses associated with it. So we should be more actually cognitive users of what kind of materials we are generating. So these non-biodegradable materials, they take a lot of time actually when they are put into the landfill. So that is actually not, that much time is not there. So of course, the use has to be more cognizant of these things. So they are lesser into the waste. Keep them in the cycle of use.
Okay, ma'am. Thank you, ma'am.
Okay. Yes, Maulana.
Good morning, ma'am.
Anji, please, good morning.
I'm from Chennai University. My question is in water conservation.
I'm sorry, your voice is cutting out.
There was a term in water conservation. There was a term evaporative cooling.
Which term?
Evaporative cooling.
Evaporative cooling. Okay. Yes. Yes.
So what is that?
Okay, I think we all can relate it to our basic school sciences. Evaporation, whenever evaporation has to take place. Evaporation means changing of water from liquid to gaseous form. So to get to that change, it requires some heat, right? So even, so evaporative cooling is whenever water will get converted from water into gaseous form, it will take up some heat with it. So that will lead to cooling. So a very good example is whenever you have water on your, say, a hand on your skin, if you are exposed to some wind, so you will feel cooler because when that water will evaporate, it will take up the heat of your body and leave a cooling effect to you. It requires some heat, right? It will use the heat of the skin. So similar concept can be put into the buildings also. Okay? There are water bodies running inside the buildings. So when water will actually, because of all the heat of the atmosphere, when water will evaporate, it will use up the heat of the atmosphere and the surrounding atmosphere can come down. Okay? Which was, I think, a lot of examples were shown on the first day that there were water bodies running inside the, there were water bodies inside all the buildings. So that is the concept. Evaporation will lead to cooling. All right. Okay, please. Thank you. Any other questions? Any questions from this center? Maulana, yes, please.
My question related to LEED, L-E-E-D.
Okay.
This type of organization.
LEED, are you talking of LEED?
Yes.
Yes, LEED is actually one of the agency. They are US based. They were one of the pioneers into this green buildings and everything. So that is leadership in energy development. Okay. So they are one of the agency which are rating the buildings. Okay. We'll be discussing the rating systems tomorrow actually.
Hello, good morning, madam.
Yes, very good morning.
Is it possible to achieve zero carbon footprint?
I'm sorry, we couldn't hear you.
Is it possible to achieve the zero carbon footprint?
Zero carbon footprint.
Yes, madam.
Again, see, there will be that is actually little difficult. But then again, I talked of something that is called a net thing can be there. If you're doing a plus somewhere, do a minus somewhere else. So that will become get to a net zero. That can be done. So we can reduce it. Yes, we can reduce it, but to some extent, we can reduce it to a lot of extent. So achieving zero, yes, more and more research, we can maybe go to that level also.
Means we can reduce it
Yes.
by 1%.
I'm sorry.
By up to 1%. Zero is not practically achievable.
Yes.
So up to by 1% is achievable.
Yes, so we can reduce it with all the measures that we have discussed. We can reduce a lot, and also we can try to do some carbon offsetting at the same time. So that net we can achieve something much closer to zero.
Okay, thank you, madam.
Okay. Okay. Yes, good morning.
Hello, ma'am. My name is Kushal. I am from Afghanistan, student
Okay.
of civil engineering and third year.
All right.
Actually, ma'am, in today's discussion, I have a problem regarding two phenomena that I didn't understand.
Okay.
The first one is bushfires and cyclones. Can you please tell me, ma'am, what is bushfires and cyclones?
Okay, let me give you an example. What happens is with all the forests and all, what happens with all the shedding of leaves and everything, if there is an increase in temperature, sometimes, what happens is if there is a little bit of rubbing amongst all the plants and everything, so it can lead to fire and all, and that can actually aggravate if it is a forest. So what is happening now these days due to this environmental impact, this bushfires is something because there are lesser trees and all the environment is, the temperature has gone up of the earth. So all these incidents break up more then. That is the reason, because there is a higher temperature of the earth now, global warming that we talk of. So these incidents happen more. And if we talk of cyclones, actually, I'm not a expert in geography, but I think that is all related to the temperature and how the earth and the land, sea and all, they are actually interacting in their respective hydrological cycle. So because of all this increase in temperature, the global warming, so these are also actually all these processes are actually happening more often. Thank you. Any questions from this center? Okay, so we'll wind up this session then. Thank you so much for the patient listening, and we'll be assembling back at 11:30 now for the next session. We'll have a tea break now. Thank you, centers.
ਆਪਣੇ ਪਰਿਵਾਰ ਦਾ ਹੈਗੇ
इसमें है कुछ ये मेरे को 304
Let me check. Centers, welcome back after the tea break. Everyone is there? Chandigarh University is there. Agrasen and Bikaner. Maulana is here. Who else is left? IEC is there? Yeah, ECA. They're not there. Is Agrasen connected to? कहाँ पर है? नहीं है ना? Should we wait for 2 minutes? Let's wait. Okay, welcome back to the second session of this third day. This session, we'll be discussing in detail about the water management part. As we all discussed in the very beginning, that water efficiency is one of the major components, the 5 components that are identified for a green building. So water management is required. So basically, I would like to start this session by actually interacting with all the nodal centers and all the participants. So when they understand the water management, some has already been told already. So can I have some inputs from the centers as to what can be done for water management in the green buildings? Chandigarh University.
Rainwater harvesting.
What are your thoughts?
You can stand up.
Water management in buildings.
Good morning, ma'am.
Yes, please. Good morning.
I'm from Chandigarh University, and my name is Praful Thakur. So, so we can go for the rainwater harvesting.
Rainwater harvesting. Okay.
Yes.
That can be one measure to actually tap the water that is coming out of rain. All right.
And that just now you told about the grey water also, usage of grey water management. The water is coming.
Water management.
Yes, grey water management. That can also be done.
All right.
You have told about that also.
All right. Okay. Any innovation you can suggest in our everyday use of a building? Say you're in a school building, you're in a college, your own campus, university campus. Can you suggest any innovations?
Reuse
Anything
of
coming in your mind?
reusage of water. That grey water system is that monument. We are using the water coming from the sinks or the household waste, except the urinal waste.
Okay, so you're suggesting reuse of the water?
Yes.
So what do you think can be reused for other purposes?
The water can be used for the purpose of gardening.
Okay. What kind of water can go into gardening then from your building use?
Sewage treated water, like.
Sewage treated water. Okay. So that will require some technical input then for a green building then to have such kind of facilities.
Yes, we have the treatment plants for that.
We'll need to have treatment plants. Yes.
Yes, our university also has the sewage treatment plant.
So there is one already there in your campus.
Yes.
Okay. And all right, please go ahead. Sorry. All right. Okay. Thank you so much. Any other input from any other student there? That was good. Thank you so much. Let's ask now. Mulana is there? Mulana? Yes. Good morning again.
Good morning, madam.
Yes, please. Any suggestions, any innovations you can suggest? Anything good you have done on your campus which we can all share as a best practice?
We have STP plant. We use recycled water in landscaping.
So you're using a treated plant for the irrigation purpose, the landscaping purposes.
Yes.
All right. Okay. Thank you.
Thank you, ma'am.
Yeah, so this is Agrese. IEC. There is no one here. The coordinator is requested to kindly have the participants seated. Bikaner. Agresen University. Any suggestions from your side? What is your thoughts on what can be done for water management in green buildings? Some background has already been given in the past classes. So what are your views? Any innovations you can suggest? Any good practices already happening around you?
Water cooling towers for managing the heat inside the building.
Water cooling towers. Yes. That is one of the solar passive technique also.
That can be used for managing the heat trapped inside the buildings instead
Okay.
of using air conditions.
Right, that is true.
In that way, we can use the rainwater harvesting also, and we can build a green building also. Both
Okay.
purposes will be solved in the one technique.
Yes, that is true. And I think one of these example was also shown in the first session.
Yes, ma'am.
Yes, that is good. Thank you.
Thank you.
Bikaner is here. Back. Bikaner is not. Anyone there in Bikaner? Dr. Purohit?
Yes, ma'am.
Yes, very good morning, Purohitji. The
Morning, ma'am.
participants are not here today.
Actually, they are just coming.
Okay, all right.
Yes,
So we were just starting a session on water management. So we were actually sharing with all the nodal centers. They were sharing what are their views, any good practices they have seen around. Some of the campuses were telling what they have done in their campuses. So we would actually like to know if you what are your thoughts on it, especially that you are in a very hot arid zone of Rajasthan. Can you hear us, Dr. Purohit?
Yes, ma'am.
Can you hear us?
Yes, ma'am.
Okay. So we just wanted to know your views on what can be done for water management and green building.
And regarding water management, the basic emphasis is to conserve water first, rather than to waste it and then try to conserve it. So
Right.
the main approach is, as in the previous sessions, also in the first lesson, 70% of the water wastage can be prevented by using the raw water itself, prior
Yes.
to purification, chlorination, something like that. Na? So that
Right.
is depending on the type or the purpose of which water is to be used. The strategy can be set for conservation and management of water. And the main thing is that awareness among the people that what
Right.
kind of water is to use for what purpose. So that seems to be an effective manner to aware the local people as well as the educated people themselves also.
Right. So training is required, education awareness is required, and no doubt use of raw water wherever possible. Okay.
Yes, ma'am.
I think one point has actually come out from this discussion also that many of us are agreeing that at least for landscaping in the buildings, there is no need to use treated water with the municipality is actually supplying us, which comes after a lot of treatment, lot of energy is going into it, lot of money is going into it. So we'll just putting together these thoughts and carrying forward these thoughts. I'll share some views on the water management in buildings. Yes. Yes, yes. So another participant here is sharing, and it was said by another one also, that there is a need to reduce the water usage anyways. So reduce the demand at the first place. And again, the emphasis again, I would say, reduce, reuse and recycle again is the strategy which can be applied even here. First of all, try to reduce the usage. Okay, so again, that is a very good and pertinent point made here. Okay. So now let's, for a background, let's see why is there a need to manage water, okay? There are large freshwater reserves, no doubt they are there, but the population is increasing, the industrial activity is increasing because of that, and at the same time we had seen in the morning that pollution is also increasing. So there is what is happening with the increasing population, the per capita demand for this water has increased, especially in towns and cities, which are again very energy intensive lifestyle, having very energy intensive lifestyle. Okay. So what has happened is the surface and the groundwater, that is the one which is very easily available to us. So that has been overexploited now. Okay. So there are all the countries, most of them, they are facing immense water scarcity. Okay. At the same time, water is scarce and the wastewater generation is also increasing at the same time. Okay. So if there are not proper measures for treatment and management, so the existing freshwater reserves are getting polluted. So what is happening? Freshwater reserves are there, but we are not very easily able to tap into those. As we say, 97% is in the glaciers, the seawater and all. That is not very, very usable for us. It requires high amount of treatment, and that kind of technology is not very easily available So what we end up using is the surface and groundwater. So what happens, that water is already overexploited, and the fresh water which is there, that we are polluting with our pollutions, with all the wastewater that we are generating, that is going into the fresh waters. So we are doing a two-pronged problem has to be tackled here. The water which is already scarce and jo hai, that is being polluted by us. Okay. So let's talk, since we are starting, let's talk first of wastewater management. So there is a lot of issues which are there. So what is happening? Our landscaping with the exotic lifestyle and all, we are using very high water consuming techniques here, lawns, fountains. We are using exotic species also of plants that we are planting. The water sprinklers and all, they use lot of water. So they are all very high water consuming, our landscaping techniques. Then even the flow water fixtures and faucets that we're using in the buildings, they are also very high flow water fixtures. Then again, in the construction processes also, since we're talking of buildings, there is inefficient use of water in the construction processes also. So the water use is not only limited to the, as we said, not only to the use of the building, but also when it is constructed. Okay. So again, solution has to be, if we want to go for a solution, it has to be a sustainable approach. Okay? Approach which can be sustained, approach which can sustain the water resource for, which can suffice our demands, but at the same time also leave sufficient for our children, for our future generations to enjoy. Okay. Now again, I'll come back to the same. We have to again go to the 3 zeros, and we can see that zero water is a big part of it. So we already understood this in the morning. So we have to go for zero water, which means in two terms, it can go in two terms. So whatever water is required for the functioning of the building, that water should be met within the site. I should not have to go outside and ask for water. And second, whatever waste is generated by the site, wastewater, that should be treated within the site and not actually putting demand on the outside treatment systems. Okay. So let's talk of, if I talk of a sustainable approach for the water. Now again, when I talk of water management, it will be the water and the wastewater. So both these things have to be tackled at the same time. So again, it will require planning and design of building functions that will integrate the issues of this water and waste management at the very early stages of the project evolution, when they are managed during the construction activity, and again during the occupancy and use of the building, again they have to be dealt with. So the problem has to be tackled right from the early inception stage of the project when they are being designed. And again, when they are being constructed, that is another opportunity where we can save water, and at first during use, which is the maximum, we can save water. Okay. Now again, the sustainable approach should finally adopt an integrated approach. An integrated approach should be there for the water supply and wastewater management. So the supply and wastewater management, they have to be integrated. Don't look at them as two different things. As again, the examples have, very good examples have come. So again, the wastewater, that can go into a water supply thing only for a different purpose. So it has to be an integrated approach. They are not two different things. They should be looked at together. Okay. So the facilities that we try to create in our building, there should be one where there is zero anthropogenic waste. So the waste that is generated due to our activity with the water waste, that should be zero. That should be our aim, which means if we are generating it, we are using it in our site itself, not getting it out of our site. Okay, so again, the broad concept, since we've already introduced this, so we have to go back to the conceptualization, the planning and design stage of the project. Okay, so at that time, we should give a major consideration to what are the raw water sources around that site from which you will actually fetch water. Okay, so what is the quality of that water and what is the yield? Now, quality will, of course, have a good impact, because if the quality is such which requires lot of treatment, then that has to go into the planning of the site. So accordingly, treatment plants will have to be put up in the site. If the water is, say, high on chlorine, if the water is high on dissolved organic solids or something like that, so to make it fit for the use, so accordingly, these things have to be planned. Okay, and then what is the yield of these raw water sources? Okay, in case they are perennial sources or they are seasonal sources, so accordingly, then you might have to think for the site, because if the site is being used after the building will be made, it will be used for all the 12 months. So even the water requirement has to be then fulfilled. And if this source is not adequate, then we have to look for adequate other sources alternate. Okay. So all these things have to be looked into when we are planning the project. Now, another consideration when we are doing the planning, which is very pertinent for this water management, is what is the topography of the area, what is the geology, and what is the population density of the service area. So that will also actually go a long way in planning how the demand can be met. Then next we have to identify what is the intended use of the water, what all areas the water will be used. Okay. And then the type of wastewater that will be generated, what kind of treatments that need to be given to the water based on if we can put it to other uses. Okay. Now, again, we have to understand these considerations. They will vary from project to project, and each solution will be unique to the type of the project, type of the users, type of the site, and type of the stakeholders which are involved for that project. So this is one exercise that must be done. Okay. Now, as we said before also, this requires a very holistic approach, which means we have to look at everything together. Okay, we have to integrate all the functions, all the water supply system, all the wastewater systems, which also includes the grey water use. And we also have to take care of the storm water management, including the rainwater harvesting. So all these things have to be looked at as a one single system that we have to design. They should all be interrelated. Okay, now next, just quickly reviewing at the construction stage. Okay, now that there is a lot of scope. The materials, the technologies that we actually select, they can be either water efficient or they can be less efficient. So that will go a long way in determining what amount of water we are using. So there is a term which is called value engineering. So value engineering of material and technology should be undertaken so that the solutions are appropriate to the project peculiarities as well as the environmental constraints. So all the materials that we are actually choosing, we did discuss few in the morning. So what kind of water is used? Say we are talking of concreting. So we can always go for there are a lot of admixtures which are available. Water reducing admixtures are there, plasticizers are there. So all these kind of techniques can also be used for all these materials and all. So they can go into the consideration for the water requirement of the site. So value engineering must be done. Okay. Then again, it is essential to establish the systems for water management so that the project teams are monitoring the water consumption. They're controlling the waste in an environmentally appropriate manner. Again, the water management, it should come in as a system. That is the only way that it will get due attention. It will get all the resources. It will get the people, resources in terms of people, in terms of money, in terms of technology, in terms of space and all those things, so that this can be taken up as a full activity so that results can be seen. Okay. Now, in case construction, including in environmental sensitive sites, there should be a compliance to the legal and statutory requirements for water management. At many places, there are many requirements that the area must be having. There might be pollution control boards, there might be having some standards that if you are releasing water, wastewater, it has to be first treated to that much of level, only then you can release it to the municipal waste systems. So there might be some standards. So you might have to provide the given level of water for the drinking purposes in that area. So in case there are environmental sensitive areas, there might be some regulatory and statutory compliances that might be applicable for the project. And as was already said, with green buildings, we have to take care that all the legal and statutory requirements are met at all the times. Now, the third aspect where this water management can actually play a big role is its performance during the use and corrective action. Okay, so it has to be monitored. It has to be compared with the benchmarks that we had produced. We'll be looking at this in detail. So they can be industry specific, building specific, or standards. Some may be given in the code. Okay, then any deviation from what was planned, corrective action should be taken. Okay. So again, we have to design systems that facilitate monitoring. If I say I want to monitor how much water is being used, I have put up a water efficient fixture. I want to see how much water reduction has taken place. So if I have to monitor it, I have to give proper facilities to monitor it. Okay. So it might require some metering. So all these things will come at the time of planning. So you have to provide proper meters at the proper place where they can be metered and seen. Appropriate metering and corrective improvements should be integrated in the design detailing itself. Okay. So that is why it is being stressed again and again. It has to be a holistic approach. Everything has to be. So if the design team was not conveyed this at the design part, so during use, what can they do at that time? That will become more costly and less efficient. So again, it is desirable to design water system taking functional homogeneity into account and facilitate function-specific corrections. And again, the solutions that we are providing, in case we are providing some solutions, they have to be very function-specific. The comfort of the users, the intended use of that system should always be met. The comfort has not to be compromised. Okay, now let's talk of the planning and design of the water management system. Okay, so first of all, we have to analyze what is our demand. We have to do a study of the assessment, or assessment has to be done on what is the demand for the water. Okay, the demand in terms of numbers, in terms of types, in terms of the numbers can vary from hour to hour, they can vary from day to day, they can vary month-wise also. Say water consumption may be high during the morning hours from 6 to 9 p.m. It may be high again during the evening hours 6 to 9 p.m. So all these kind of things, or there is more water consumption during summers, lesser in winters, all those kind of things, it can vary. Okay. Then what is the availability of water? That was also emphasized before. What are the water resources that are there? Then there might be some project constraints that might apply. Okay. So say a project constraint is such that the site is somewhere where the water natural might not be available. So you might have to start looking for other alternatives. Okay, so this is just an example. So there can be project constraints also. So everything should be identified at the planning stage, whatever is affecting the water planning there. Okay, and what will be the sourcing, water sourcing from which other sources, outside, inside, what can be done. Okay. Now next, when we're talking of big buildings, okay, one important system that comes into place is the hot water systems that is provided in all the actually big buildings that are there somewhere. Many buildings, it is a requirement to give a 24-hour hot water system. So that has to come into the planning and design itself. Okay. Then strategies has to be there for water efficiency. You have made the water available, now it should be used efficiently. So that strategies have to be there. Next, we have to have separate strategies. The idea why these terms have been said separately, because they have to be tackled separately. Again, water conservation, lesser use of water. Okay, so that has to be there. Then again, all the detailing of the water supply system components. Okay, when this design is done by civil engineers, the water supply system. So those designs have to be sustainable. Okay, sustainable in the sense, as one part of it again is the durability part. They should be durable. Minimum leakages, all those types. And many people were giving an example that water can be reused. Okay, so if you want to reuse that water, you'll have to give some pipes so that water can be recirculated back. Otherwise, say the water from your kitchen sinks after washing your utensils, that is right now straight away going into the municipal sewage. That is getting mixed with the sewage. Whereas now that can be given a lesser treatment and made usable for flushing and all those kind of watering needs of the landscapes. So that it doesn't get mixed with the sewage, you have to provide separate plumbing line where it goes to the STP, and then from STP it can be reused. So separate plumbing lines and all those kind of things will come into consideration. So that is where your detailing of the water supply system has to come. We have to put in all these things. So if you have planned for this grey water reuse, it has to be done. In case the black water treatment has been also planned, so accordingly, all the system has to be designed for that. Okay, now let's look at a very quick example. This is a very typical scheme showing the general components of water management system. Now, one component is, of course, the supply. So we are getting supply from the municipal water. We might be using a bore well, river, canal. Then there is rainwater storage also can be one of the supply system. Okay. Then you might be getting water from your STP that you have recycled. That can be one of your supply. Now, demand will be for the commercial occupants. They will be flushing, office use and residents, and all other residents. They will also be at the demand end of the cycle. And again, there is another component involved, which is the recycling of the wastewater and rainwater usage. Okay, somebody gave a very good example of cooling tower makeup, so that can be done. So cooling tower mein jo pani dalna hai, use it from your site itself. Okay, then project landscaping, which is a major again use of with big sites where big gardens are there. So that is a major component where water is getting used. So if we try to see here, everything is interconnected. The whole idea is, after identifying these components, you have to first identify which are the components, and then we can see how they can be interlinked and it is very well shown how they are. So in one example to the right, you can see the recycled water from STP, okay, the demand and supply, they're all interconnected to each other. So that water can go into the demand cycle, and again, the supply and demand, they are connected, the rain cycle, all these things have to be connected. So all these connections have to be made, which will actually then make your system an integrated system, which has looked into the holistic approach, all right? So such kind of analysis should be done at the time of planning, okay? Okay, so now when I talk of the details, so we already said for the planning part, the quality and quantity of the water which will be available, that kind of study has to be done. Then what is the domestic water use profile? What is the scope of recycled water use? Now, if I'm saying that my water use profile is this, morning hours more requirement, summer hours more requirement. Now, out of this, how much can be actually tackled using recycled water use? Say car washing is a major activity there. So if that can be used by, that can be tackled using recycled water use. So that has to be then identified. Then again, system has to be conceptualized and integrated with other water systems. So there might be other water systems, like someone might be having rainwater harvesting. So there is a storage of water which is there. So that can be conceptualized and integrated with the supply, which is coming inside the building, say for flushing or even for washing utensils or laundry purposes, all those kind of things. Okay. Then there has to be planning for collection and treatment systems. So how the wastewater will be collected and how it will be treated. Okay. So there has to be independent sewage and sewage treatment plants. Okay. Then on-site grey water and reuse, which everyone has well emphasized, which has been well understood. I'm happy about that. So on-site, you have to try to use your grey water itself. So grey water actually is the one which is coming out of the kitchen sinks. So that is less toxic and hazardous. And the water which is coming out of the sewage, that is with the sewage, that becomes black water, because which is highly toxic, and that requires a lot of treatment to make it reusable. Okay. And in many cases, we should also consider sludge drying and use of manure, recycle, and hygiene considerations. So we talked of waterless urinals. An example was also given just now before the session, that waterless urinals we had shown also. So that all those feces and all that waste, okay, that can go in as sludge. And even after your water treatment from your STPs, the sludge that is coming, that sludge, instead of fully putting it in, disposing it, putting it into landfill or something like that, can be again used in your site itself as a manure. It can be recycled, and for hygiene considerations, it can be properly planned. Okay. So the sludge and all those things from your STP should also be tried to used on the site itself. Okay. Now during construction, let's see what can we do at that time. Okay. Now what happens? Most of the time, conventionally, the way we are using the water during construction, the municipal supply water, most of the time it gets wasted on the construction site. I have seen this myself. I have a personal experience that I have seen. There's a construction site and they have exactly something like this. They have a tank and it just gets filled up and it is just overflowing. You can see, I'm not sure if you can see, but the tank is actually overflowing here. This water is actually overflowing here. So they do not stop the water supply even after the tank has been filled, and I have actually personally seen this happening. So there is better site management that is required. Now another wastage, there is potable water which is used for curing. Is potable water, drinkable water really required for curing? I can understand there are some standards of water, the water, some quality is required when you are using it for the concrete or the mixing and batching. That is water quality is there in the standard, but for curing, there is really no need for potable water, and we are just throwing the water like that. Okay. Then sometimes even construction water, the way it is stored for the use of construction, it is mismanaged. We can see here the way it is stored, there is a lot of chances it will get evaporated and get wasted. It is not properly covered. Okay, so there is a mismanagement even in the storage of the construction water that we procure. Okay. So again, let's see what we can do. Okay, again, only the authorized sources which are there for the construction, those should be used. Use of treated wastewater from appropriate sources with quality of treated wastewater conforming to the quality required for construction activity. Okay, an example that I have just given you. Okay, quality of water required for making a mix concrete mix versus what is required for curing is not the same. So we have to give due consideration that what kind of quality water we are using where. Okay. Again, environmental provisions sometimes are there for the sourcing of water also. So what kind of water source you use, so how much already it might have the parameters. So all those, if they are applicable, in case something is applicable to your site, that should be given due consideration, statutory requirements. Okay. Use of potable water, which is drinking water, which has come after a lot of treatment happening to it, lot of money has gone into it, lot of energy has gone into it. So don't use it for construction unless otherwise required for your specific use. Okay. Again, inadvertent use of non-potable, what happens with this? But again, this comes with a word of caution. Okay. So in case you're making non-potable water available on your site for some use, there has to be proper marking so that accidentally that water is not used for drinking purposes, because there is a lot of construction force on the site. There are families which are staying there, construction work people. So this also has to come with a caution then. Okay. So there should be proper distinct system with proper appropriate markings. What is potable water and what is non-potable water. Okay. Now other types of use during construction. Okay. What we can go for, there are a lot of curing chemicals that can be sprayed on concrete instead of free flowing water. These kind of materials are available these days for curing. Okay. We can also, concrete structures can be covered with cloth or gunny bags before spraying of water, so that the water actually is absorbed by those gunny bags and it actually acts as a layer then, and it doesn't flow away. It shouldn't just flow away. Okay. I think it is the same concept as we say that land which has trees, it will actually, water will actually be locked in it and it will not just flow. Okay. Then we can also go for techniques like ponds can be made around the curing to avoid water flowing away from the flat surface. Okay, so you can give little ditches around, so water will store there, that you can use again then. Okay, if whatever goes away. Okay, again, in case you have sunken slabs, you have an advantage there. You can do some water ponding there. Okay, keep the water stagnant there. It will serve the purpose of the curing number of days that are required. Okay. Lot of quick dry cements are available these days. Curing and mixtures are available. They can actually be used for water minimization. But again, word of caution, everything has to be seen. If you're using one alternate for the other, you have to see at the other consequences also. Okay. Okay. Now again, let's understand. It's not that our standards are not addressing it. If you look at the structural design section 5A concrete of the National Building Code. Okay. So it is very clearly stating what is the water quality required for concrete. So as engineers, when we are doing all this concrete mixing and all on the sites, we should go for all those standards, look at what is required, and then actually compare if that tap water, drinking water is really what is required here. Okay, so due diligence is required here. Okay. There are many pre-mixed concretes. These days, RMCs are very much, ready-mix concretes are available. So loss of water during mixing can be prevented that way in case there is a lot of concrete requirement. So that can be, options can be done. Okay. Again, wastage of construction water in piping network as well as storage tanks can be prevented. I did show you. So storage tanks which are there, sometimes piping, there are a lot of leaks, storage tanks, the water is leaking. All those things should be prevented because that is nothing but water lost and not accounted for at all. Again, water consumption should be monitored. Okay, so there can be daily logs that can be maintained on how what water was used, what was done to control the wastage that day, and how was it efficiently used. So have proper logs. Have someone put there what was used. Okay. Again, this is again a word of caution. So again, if you're going for water efficient construction technologies, other implications, they should be given due diligence. Okay. Now, control and use of dewatering output. Okay, dewatering, that is a very common activity in all the construction sites. We all understand. Many times we require to dewater to make some construction there, make a structure there. So dewatering is essential for carrying out construction works below water table. So extent of the dewatering should be decided on based on the structural considerations. Okay, should not be there. It should be proper designing should be there. How much is required? That only should be done because that is nothing but natural water of the soil that we're taking out. So whatever level it is required for the structural performance, only that much should be done. Okay, that is one major activity. Okay. Now the wastewater that is coming at the construction sites. Okay. So now again, so it might happen. Construction sites may not have proper provisions. Since it is a temporary site, it might happen. They might not have proper provisions to actually treat their wastewater. So in that case, they should make arrangements to take that wastewater out of their site and give it proper treatment. Okay. Again, a water consumption reduction and again reuse of wastewater, that opportunities have to be identified all the times. Okay, even small to small opportunities, they should be identified. Wastewater at construction sites may contain residues of construction materials. We have to be very cognizant of that. Construction site wastewater, we may have cement, sand, bentonite slurry, oils, domestic waste, all these kind of things might be there. Okay, oils and domestic can also be there because there are people living on the construction site also. Construction workforce is there, families are living there. Okay, so we have to give due diligence to planning when we are doing that. Okay, it should be possible to treat water, especially containing residues of construction material, and reuse the same in construction. I think we can all understand that. Cement, sand, bentonite slurry, all these can be very, very easily removed. Sedimentation is a very simple process. Very easily it can be reused on your site. Okay. Again, in case we are talking of oils, domestic waste, then there has to be proper planning of what kind of treatment shall be done. Okay. Okay, so next, after construction, let's talk of during the use of the building. So there are a lot of things that we can do for the water conservation around the house also when we are using the building actually for its intended use. So use of raw water in place of fresh water wherever possible. Okay, so separate plumbing lines should be there, as I've already discussed. So in case for lawn mowing, for laundry purposes, okay, for flushing, you say, I don't want to use the municipal treated water, okay, the potable water. So you can have a separate plumbing line which might be directly sourcing from some sea or something like that. So raw water directly coming and not necessarily the municipal water. Okay. Or even if you're putting some rainwater systems, rainwater harvesting system, so that water you want to directly use for this plumbing and all those things. So have the lines directly put. Okay. Now, again, this issue was, as I highlighted before, what happens, we have high flow and water inefficient fixtures at many places. Okay. So there are sensors which are available there. Okay. The very common example these days, especially in malls and all those things, in most of the buildings, you will see this. These have become very popular. So again, as I said earlier, it used to be kind of a luxury thing. Now, with so much of research going on, these are commonly available. So everyone can put it now. So with more and more research happening, so green is affordable now. Green is affordable, okay? There are a lot of auto control valves which are available, very commonly being used these days. There are also pressure reducing devices which you can use for your water efficient fixtures. Let's look at what is that. Now, auto control valves. So what exactly it does, it is actually self-operating valve is there, also called as a magic eye sometimes. So it can result in water saving. The sensor taps has automatic on and off flow control. It's convenient, it is hygienic, and also water saving. It can work under normal water pressure also. It doesn't require special pressure to be given. Okay, so it can be actually functioned for distance, timing, all those kinds of things. So distance of your hand from that or timing, you can make it based on time or maybe based on the distance from the source. Say if I put my hand up till this point close to the tap, it will work. So that way it can actually sense whether it is to be used or not. Pressure reducing devices are there. Okay, there are aerators, there are pressure inhibitors, which actually ensure that there is a constant flow. Okay, so aerators, they can result in flow rates as low as 2 liters per minute, which is very much adequate for, if you want to wash your hands, this much is enough. We don't need to have very high flows. Okay, so again, flow regulators can also be put in case you have that kind of technology available at your place. Okay. Water efficient fixtures, again, a part of this. So minimum indoor water usage by installing efficient water fixtures. Okay. So again, when you're trying to put up all these water fixtures, try to do some survey. Okay. What are the green products available around? Go for all the catalogs which are available. So instead of just do some homework on what green material you can use at this alternative. Okay. There are very ultra high efficiency fixtures also. They are also available in market these days. Again, especially for basins, urinals, toilets, we should have low or controlled flow water fixtures. We should try to do that. So slow the flow is our motto. Okay. Use low flushing capacity systems with urinals. Dry urinals are also there, also shown to you. Composting toilets is one of the option. Okay, composting toilet, that is a very old concept also. So here, all the feces, it is being composted actually. There is no water being used to wash it away. Okay, so especially with toilets, we would say that what we are doing is all this actually the waste that is generated from this human activity, the feces, is very toxic, is hazardous. And we are saying water is already scarce for us, and we are just adding those feces to the water and polluting what is already less for us and making it even more not available to us. Then we are putting money to treat it. First we are polluting it, then we are treating it, money putting in that also. And wo jo treat hoकर आएगा, how many of us might not even be very much comfortable drinking it if I tell you that it is treated. So it is not a very good idea. So composting is a very good option actually. Okay, so that feces can directly be, because it is very well biodegradable, it can be used as later as manure and all in your site also. So it is a very good option. And I was reading also somewhere, even the Indian Railways, they have a target in the next 10-15 years, they will be going for all composting toilets on their facilities. Okay, aeration on all taps should be done. Okay, that reduces the water coming out of that tap when it is on. Okay, again, another thing is use recirculation system for centralized hot water distribution. Okay, in case you have a centralized hot water distribution facility in your building, okay, there is a lot of energy that has gone into heating that water. Okay, just using it once may not actually use up all the heat. It is still heated. The water is still hot after heat. So you can recirculate it and use it for some other purposes. Okay, there are dual flushing or high efficiency toilets. I think dual flushing, we all have seen it, very common these days. Okay, so depending on the type of activity, you can go for a lesser water use also. Okay, this was already shown also. This is one of the waterless urinal, and I have actually I'm in Chandigarh. I have actually seen this being used, and people are very happy using it. So it requires no flushing. What happens is a fine film is inserted inside the urinal. It is practically frictionless. So there is no stains or odors. So it is frictionless. Nothing sticks to it. No sticking, no stains, no odors. Okay. So there is actually a floating cartridge which is filled like an oil-like substance that absorbs all the fluids. It fights the bacteria and also soaks the odors. So this cartridge is also recyclable then at the end. And actually per flushing, we are using 6 to 10 liters of water. In this case, we will be saving that. Okay, another example of a waterless urinal, composting toilet. Okay. Now let's talk of, after the system, let's talk of plumbing systems for flushing. Okay, provide appropriate infrastructure so that the use of treated grey water is there. Okay, again, as said, you have to provide the system. If you want to use that treated grey water for plumbing, you have to provide plumbing lines so that that treated water can come back into your flushes. Okay, so all those things have to be taken care in the design part itself. Okay, domestic appliances. Okay, dishwashers, washing machines are very common. I would say in India also, dishwashers in our economy not very common, but now it is actually picking up a lot. Western culture, they use a lot of dishwashers. Very, very water intensive activity. Even all those fully automatic washing machines, very water intensive. So about 20% of household water uses account of these kind of appliances. So you can go for options if you have time, go for machine wash, hand wash. You have to see, I mean, you really need that or not. So as cognizant users, see, it's not bad to have a facility. We say we have developed, we have grown, okay? But then again, we can be using that cognizantly also. Okay, not necessarily if you have time, you can go for hand washing, other kind of techniques also. Okay, and even in this washing machines and all, these days star rated appliances are coming. They are very common. The B rated star appliances, just like ACs are star rated, fridges are there, even washing machines are there. So go for more efficient appliances in terms of energy usage also and water usage also. Now, again, a very, very important part when we say even for like energy, it is said energy when it is sent for the grid, there are a lot of power losses, distribution losses are there in the way. Okay, similarly, water, what is supplied to what is actually received at the houses down at the end, there is a lot of losses there, and because there is a lot of leakage that is happening there. So we have to check for leaks at all the times. Okay, check for overflows. Okay, you should have systems wherein you are detecting leaks automatically. Okay, I actually had an opportunity in one of the conference. We were looking at one of the university student. He had developed a technology wherein they were putting some sensors at one end of the pipe. They had already built it in. They put in the sensors. So it was actually based on the water flow pressure it was measuring. Okay, at one end to the other end. So if the water pressure flow is actually getting reduced, it means the water has reduced there, which means in between some loss has occurred. So it can be very readily used to go and maintain that leak there. Okay, so at the designing part itself, we should incorporate such things in our plumbing systems. Okay, so these kind of sensors, they have to be inbuilt inside the pipes. Okay, if you say after the building is done, then I'd start breaking all the walls and now putting it break the pipe and put in all these sensors, that is not feasible. It has to be done at the planning stage itself. So automatically it will detect this leaks. For this kind of technology, it will require another management kind of thing wherein you are also monitoring these results. Otherwise, it is of no use. So somebody should be monitoring what are the floor datas and all those things. So an appropriate facility should be there for all those maintenance activities at the same time. A very common technology these days, there are alarms. There are shut-off alarms that are there, especially with the overhead tanks. Okay, whenever water is full, I have seen that around. So there is a voice that comes that water is flowing, water is flowing. That can be done. It can be a good system. So, or you can have a shut-off valve. Anyways, it can shut off like automatic shut-off can be then whenever the supply is full. So all these kind of things should be done. Okay. Now let's talk of the heat system. Okay. Now, what happens is sometimes when the mains pressure is giving hot water, they tend to use more water than a household with a gravity system. So a place where you're giving water with pressure, okay, versus where you're giving water with gravity. Okay, so pressure, wherever you're giving it pressure, वहाँ पे कभी कम आएगा, कभी ज़्यादा आएगा. We will have tendency. A good example, पता है आज कम भी आ सकता है ज़्यादा. I will unnecessarily keep on storing it. नहीं use at the end of the day, I will throw that bucket of the water. So what happened? If I know there is a sustained supply of water coming to me, okay, so I will try to do that accordingly. So just a little example. So there lot of things can be done here. Okay, so again, high flow rates also come from hot taps, particularly showers. That also happens. If there is hot water coming, it will be always higher supply. Okay, so what can be done? If you can go for smaller bore pipes can be small bores. Okay, so the dead lag which is there always, okay, this will be small. Okay, mostly hot water aata hai, usse pehle kuch cold water run karna padta so that hot water comes in. So if there is a smaller bore pipe, smaller dia, smaller area, volume of the water coming out reduced. Okay, we have reduced that by reducing the size. Okay, and then other advantage, taps will run hot or cold very quickly with this kind of technique. If I have another technique of regulated tap aerators, so with tap aerators, we get an illusion that we are getting very high flow water. Okay, although it is saving water, because we all have a tendency to have quite high water in our hands, even when we are brushing our teeth and all those kind of things. And this also helps in eliminating splashing, which is another water wastage. Okay, there are also low water use showers that are available. Okay, very significant savings. And I think my personal feeling is showers, there is really no need to use showers. We can all actually do our bathing activity in 1 or 1.5 bucket. That is it. But showers, we just keep on wasting water. So anyways, that is a personal choice. So we can all look into these activities also. Okay. So with the low water use showers, it feels like a power shower due to its pressure actually. So that is even more soothing effect. Then there are other flow regulations that can be done. Okay. Wastes when outlets left running that are there. Most of the times taps are left running when they are not really required. So you have to regulate such flows. Okay. Through automatic means, man-made means, or through management systems. However, this has to be done. Okay. Another thing that can be done with your plumbing and heating system design, the length of hot water pipes can be reduced. Okay. So this will reduce the volume of water that has to be drawn each time the tap or the shower is used. Of course, if there is a lesser length of the pipe, so lesser amount of volume has to be actually supplied there. Okay. So water fittings grouped closely around hot water source. Okay, जहाँ पर आपको hot water source देना है, so water fitting should be around that so that the hot water doesn't have to travel lot of distance. जितना travel ज़्यादा distance it has to do, it will get actually there will be loss of heat and all those things. So you'll be putting in more energy to maintain that kind of temperatures. Okay, so layout, even your layouts, you should be such that you have to minimize distance to the most frequently used fittings, typically kitchen sinks. Okay. Places where water is being used very frequently, so have your water sources there only, so that there is minimum distance for the water to travel to that frequent source, minimum losses then, because we all understand frictional losses, all those kind of losses will be there. Okay, we all I think we can all relate back to that Bernoulli's equations, the 3 head losses, all those things. So they will be there. Okay, so try to reduce that demands. Okay. Hot water pipes should always be placed over cold water pipes to reduce heat transfer. Okay, that will always help. Okay, this will help if you actually put the hot water pipes over the cold water pipes. Okay, then long pipes, they should be insulated to prevent any heat loss and gain. If you're carrying hot water, try to put some insulation on those pipes so that heat losses are lesser. Okay, now coming to the next aspect, which is on the gray water treatment. Okay, so all the gray water, kitchen sinks and all, that should be treated in situ, on site, in situ. It has to be treated and used so that you're not polluting the municipal streams and reducing the consumption of fresh water at the same time. Okay. One of the compliance option, if I talk of green buildings, I think this must have been discussed also, or at least 75% of the gray water the site should aim to generate from use and recycle. Okay. Again, flushing, irrigation, makeup water for air conditioning system, they can be very easily used, this treated grey water. Okay. But again, we should always ensure saying that I have to use treated water doesn't mean that the quality should go down. So whatever is the requirements, the standards that the water has to meet, they should be met. Okay. The required amount of treatment should be given. Okay. These were just few pictures I thought of sharing. You can see here, what they're doing here, these are, you see the planters here, what the purpose, it is serving two purposes here. Green, first of all, there is plantation here, it is looking good also. And plus, it is what it is doing is actually carrying some copper pipings beneath it, which is delivering the grey water. So this is how they have incorporated a separate plumbing system in their system. So this building had actually done it later. They couldn't do it at the planning stage, so they have gone for the rehabilitation part as a green building. So there are many options. So design and innovation has no limits. Okay, so it is looking good and it is serving many purposes. Okay, now you look here in the picture below. This is a rainwater catchment system with cisterns. And if you see what I'm trying to show here is the way they have incorporated it. It is looking good also. Aesthetically, it is looking good. And it is placed at a place very close to the building. So it is not at a very far off place in the site. Okay, so it is very readily also available to them. Plumbing and all those things will be reduced here. Okay, distance is less. It is very close, very actually outside, just outside the building. Landscaping. Okay, many of us agreed on this at the start only, that landscaping is using much of water. So again, maximize tree plantation in landscape area. Okay, native vegetation. Try to use the native vegetation, the vegetation which is of that area. Okay. Now, if I try to put very exotic plants which require a lot of water and try to put that in a very arid region which is very dry, it will require a lot of water. Where will I get water? In an arid region, in a dry region. Okay, so try to have native vegetation. Okay, cactus can grow well in an arid region. Why don't you put up cactus? It will be green also and it is plantation also. It will hold your soil also. All the purposes are being solved. Okay, so just you have to use the native vegetation, all the trees and shrubs, they will go well. Okay. Xeriscaping, I think that term must have been introduced. So that is planting the dry climate plants around the building as they require less water. So plants which are requiring less water, try to put those. So landscaping needs anyways, they get reduced, irrigation needs. Okay, drip irrigation is a very effective technique. Okay, drip irrigation, self-closing nozzles can be put there. Even moisture control sensors can be put. So based on the moisture of this land which has to be irrigated, accordingly the water will be supplied. Okay, whatever is the deficit, accordingly water will be supplied. Okay. Again, water fountain concept, that is very that can be actually very I would say judicially used, I would say in here. So try to minimize that or try to reuse that water however it can. That is using a lot of energy also. Okay, next another thing we can do is the plant species, try to group them as per their water requirements. Some species require less, some require more. So if you group them accordingly, you can actually cater to their needs according to the groups and water can be effectively used. Okay. Again, gardening ke liye use raw water, recycle grey water, compost and mulches. Okay, they are very much effective, especially mulches. You must have seen in many places there is a red kind of powdery kind of thing that is spread over the plants. Okay? It looks good aesthetically, plus it serves the purpose. That is a mulch. What it does is it is a barrier on the soil, so the natural evaporation from the soil will be reduced. So the water requirement will reduce. Okay, so it will be very effective then. Okay. Again, storm water, rainwater that is coming to you naturally, we have to use it to the maximum. So try that it is not just running off. Okay, so try to have pervious concrete pavements. Pavements, you want concrete pavement, okay, that can be pervious also. There are actually tiles which have spaces in between, so that will become pervious so that the water can percolate inside. So grass borders are there. Okay, this is one example I found. This we can actually see this is a very dry, arid climate, and they have done landscaping, and I think they have done a good job with it. They are doing landscaping. They are using plants according to the climate that they have. Now, again, the best compliance is again integrated approach of water supply and wastewater management. Okay, so it can be significantly mitigated through adoption of treatment and processing before disposal and adopting waste to energy technologies. Okay, before just dumping the water as waste, try to use it again. Okay, it reduces the quantity of waste, improves the quality to meet the required pollution control standards and regulations. And again, we are generating substantial quantity of resources and energy at the same time. Okay. But talk of the building complex, township level, opportunities for water efficiency and waste management are large. Okay, that was building. But talk of now the entire complex or entire township. So rainwater harvesting and irrigation practices can be seen. Just a little details about, okay, what is rainwater harvesting? We are collecting and storing the rainwater. Then again, the water is aimed to be used for surface and groundwater harvesting, prevention of losses through evaporation, seepage, and other hydrological study should be done. Okay. Again, the rainwater which is collected, it can be stored for direct use or it can be recharged into the groundwater, but that should again be with a caution so that we are not actually polluting the groundwater with the water that we are percolating inside. We should be very cautious about that. Okay. So again, there are two approaches if we talk technically. So direct for the direct use, so domestic and irrigation purposes, you can use this water directly collected in natural or man-made structures such as rivers. You can build sand filter bed. You can build ponds. You can put rooftop rainwater collection structures also. You can put tanks and all those kind of things to collect that water. Okay. So if I talk of the rooftop, okay. So the rainwater system, collection system augments the water demands by collecting rainwater from roof and diverting it to specially designed storage or recharge tanks as per requirement so that then it can be treated if required. Okay, if I give sloping roofs, that will be helpful here. Evaporation losses are small. Collection is very efficient, even to the order of 85%. Okay, rainwater may be collected on any kind of roof, although, okay. Tiled or metal roofs are easier to use for the purpose, and a smooth surface for the roof will help in water flow and collection. So we can keep these things in mind if we are saying that we have to directly use this water on the rooftop if we are collecting it. Okay, some precautions for the rooftop to be effective. Okay, avoid overhanging of trees above the roof to prevent leaves and bird droppings falling on the roof because that will again contaminate the water. Do not allow the first rainfall to enter the tank. Okay, divert it away from the tank. Although human or animal coliforms are not involved, bird droppings or lizard feces and other airborne dirts are also to be washed away from the roof. We have to keep that in mind. Okay, filter the water on entering the tank by suitable filters. We should apply suitable filters. Cleaning and even the filters and tanks, they should be cleaned regularly. Okay, seal the tanks to keep the sunlight out, so that there is no algae growth also. There are no mosquitoes, lizards or birds. Okay, that is very important. Okay? If you're storing that water, it should be to a good quality. Okay, try to also disinfect such tanks by bleaching. That is very common approach. Okay, now one was the direct use. A second approach, if you're trying to recharge the groundwater. Okay, so there are various recharge structures that you can make for that. So they are not only arresting the water, but they're also promoting the water percolation through soil strata. Okay, or especially if the aquifers are depleting. And I think an example was given for this on the first day. Okay. Now again, a proper geotechnical investigation, meteorological and hydrological investigations must be done before putting such systems in. Okay. So another for, if I talk of a township level water management or a pura complex, so irrigation practices have to be seen. Okay. Use of chemicals which are likely to harm aquatic life such as chlorine, bromine, they should be avoided in our irrigation practices. Okay. Water features, maintenance activities that do not create habitat for mosquitoes. Okay. With your water activities, irrigation, you do not want to then again create mosquito menace then. Keep that in mind. Water features shall be designed such that they match or mimic the water in the natural environment. and water features that are incompatible with the local in context, like a lake in a desert, shall be avoided. Okay. So as far as possible, when we talk of green building, so the finished surfaces after the building is made, when it is used, the finished surfaces should be as far as possible close to the natural topology of the area. So try to have such kind of water bodies around. Again, if you're using volumes of rainwater or water from other non-potable sources, if they are available on your site, they should be estimated, they should be designed and actually integrated to be used. Okay, try to don't just rely on the potable water that the municipal will supply you. Try to account for all these supplies also. That has to be done. Okay. Again, design and maintain the water features as natural ecosystem with water sources, plants, aquatic organisms appropriate for local conditions. So if a pond is there, we can actually serve a lot of purposes. If you're actually with a rainwater harvesting system, say you're putting it, storing the water in terms of a pond. So in case there are animals around, they can also use that water for their drinking purpose, and all those kind of purposes can be diverted for other purposes then also. Okay, so we should give due diligence to that. So what is the natural usage around that area? Okay. Again, many times there are many beneficial bacteria, enzymes, oxygen-based additives which are available. They can also be used to enhance the quality of the water features. Okay. Again, if we have natural swimming pools that we are using, then other features, they should require some additional treatment, such as ozonation or thermal treatments. They should be properly given. So the idea is, if you're putting the water, collecting it through rainwater or anything, so you should give it proper treatment so that it is fit for the purpose for which it is to be used later on. Okay. Xeriscaping, as said, turf, as I told you, turf grasses are there. They should be selected, regional appropriate. They are actually do not use lot of water. Okay. Now again, there can be a subsurface drainage system also that can be planned, which for areas covered with turf to collect excess water for reuse. Sometimes if there is excess water from irrigation, you can have a separate subsurface drainage system which will collect that extra water that might be running off. So that can be done. Okay. I think we've discussed this. Okay. Now coming to the most important, we've given all the technology and everything, but there is another very important thing which actually will close this loop of water conservation, which is about educating the users, okay, which was also said by someone else also. So we have to educate the users. So it is not only about innovation and good design practices, it is also about building an understanding among the consumers that they have to work together to achieve this target of energy efficiency, water efficiency, and greener environment. Okay, so we have to actually educate people. They should know that there is water scarcity. Sometimes people don't even know because they are getting water supply 24 hours. So they don't even realize that there are other people who don't even have water to drink. Forget about bathing and washing cars and all those things. We have to generate proper awareness. Okay, so that there has to be proper signage, proper awareness camps at the point of use. Okay, put proper signage. Do not close the water when not in use. All those kind of things. So they can be done. Proper signage. Okay. So this will all become a part of your building management system that we talked of in the morning. Okay. The conservation of water. So if you do that, it will reduce the wastewater also and energy cost also. Okay, they can be educated people about that. Okay. Again, they will be able to identify the problems. They will be able to think innovatively. Okay. Again, it is not about the intangible, but also the tangible benefits associated with it. Okay. So basically, we have to understand it is our common sense and realization that our planet cannot give forever. So our planet cannot be giving us forever. Okay. So we have to ensure that future generations that enjoy the benefits of the abundant fresh water which is available now. Okay. But later it will not be. So we have to understand because of our decisions now, we don't do something that it is not available for the future. Okay. So we have to understand water is a wealth and it is high time that we try to save it. Okay. Thank you. So that was on my presentation. So any questions? I hope I've been able to give you some idea of what all treatments and what all strategies that need to be adopted for water, wastewater, everything has to be looked at as a complete system in a holistic way. Any questions? Not from here. Centers, any questions? Anything you would like to share? Yes, please.
Ma'am, I'm Gurnaam Prasad. I have a question
Ji, please.
about this water management system.
Okay.
Actually, I have learned, I have read about that, only 3 to 4% of water is drinkable. Okay. And yes, most of about 70% of water is hard water. So, is there any process which we can treat it or convert it into soft water so that it can be used in purest form for drinking purposes and for building purposes as well? Because I have heard about that reverse osmosis technique.
Yes.
Yes. Apart from that technique, is there any other process which is convenient and cost efficient technique so that the hold this the extinction of water can be resolved?
See,
Is there
actually,
any?
all the water that is coming to you in the taps, so municipal is actually treating all that water. What you're talking of, all that hard water is actually being converted into soft water only. So there
Yes,
are a
ma'am.
lot of techniques that there are chemicals that are added to it that can be done. So there are a lot of processes, all the normal treatment plant, effluent treatment plants and all those things. So water that is coming to the taps, that is coming after all these treatments.
Yeah, ma'am. Actually, I want to ask that sea is composed of 70% of this earth.
Right.
Yeah, so we can make some type of this, organize this into some treatment which can convert it can reduce the scarcity of water as well.
Yes,
Is
that
there
is
any?
what is. I did mention that that water which is available there needs to be. It requires lot of energy and money actually. It's very expensive
Yeah,
process
yeah,
because there
it
is
is.
lot
Yeah,
of
yeah.
research which
It
is
is
happening in
expensive.
this area also. So how that water can be actually utilized. But
Yeah,
again, the
actually,
issue is we are polluting those sources also at the same time. So there is
yes.
lot of hue and cry also about that. So, but the thing is, before actually thinking about tapping into those sources, you should first stop polluting those sources. Okay,
Yeah,
so that is also one thing that should be done. And again, that is a very good suggestion. No doubt that water is there. We have to stop
yes, ma'am.
polluting it also. We are polluting those waters also. And inside, whatever required we can do. Apart from reverse osmosis, there are many other techniques that are available.
Yes, ma'am. Our main focus is to focus just on to this treatment, just to make it cost efficient, so that the water scarcity can be overcome by this. Any our utmost requirement is to research on that phenomena. So we will have to research on that water treatment plant, which can
Yes.
convert the hard water into soft water.
Yes, there are techniques available, and yes, more research can, of course, be done on this aspect. Yes, that's a very good addition. Thank you.
Yes, ma'am. Welcome.
Good afternoon, ma'am.
Yes, very good afternoon.
Myself, Siddharth Sharma from MLB University,
Okay.
Bulana. I want to ask a question, madam. What are the constraints related to use of grey water?
Related to reuse of grey water.
Yes, ma'am.
Okay, see, constraint-wise, it is like the grey water, that is the water which mostly has, things like oil and all those soap, those kind of things, that is kitchen sink and all. So if you give it proper treatment, so depending on the type of treatment you give it, you can put in a full-fledged treatment plant. You can make it actually fit for drinking also. So the constraint is only on the type of technology you're applying it. So it can be actually put to as type of use depending on the treatment you give it. But again, you have to make sure then that you are actually supplying that water again to the required place. If you're saying you're wanting to use it, you have to give proper infrastructure so that it can be used. So treatment can be done to any level you like. Treatment can be done. Okay. Any other questions? Bikaner is there?
Hello.
Do you have any questions?
Hello, ma'am.
Yes, please.
Ma'am, what are the practical treatments that we can apply to grey water? What are the practical situations, or what are the practical ways how we can implement that for the purification and use for drinking purposes?
Okay. See, one very common thing that is used is for the, especially for the water that is coming out of all these restaurants and kitchen. One is the oil and grease trap. That is very one common thing, because oil is something which is always floating at the top. So oil and grease trap is something wherein you make the water stand for some time at a place. So oil and water that is all collected at the top, that can be removed, and then that water can again be reused. That is one type of thing that can be done. Then again, if it is having, you know, all the food particles and all those kind of things, so you can put it through a filter bed of stones and all those things, that can help. Then sedimentation is one thing which can be done, make it stand for some time, so those kinds of things can also go off. And I think then that kind of water can be very easily used for your planting of gardens and all those kind of things. So these are some very practical things that I use, and I'll quote an example here also, especially in Chandigarh. All the restaurants, they are required to have an oil and grease trap that is required by the Pollution Control Board for them. So that
Yes,
before they throw that water into the municipal seas and all those things, so that oil should be removed, because oil is very harmful. That will just create a lot of rust and congestion inside that all the pipes and all. So that
Yes,
is being done very commonly now. And at the on-site, you can put all these technologies to use.
Ma'am, okay, you are.
Chlorination and all those things to make it even more pure.
Ma'am, yes, ma'am, but you are saying there is a different systems that requires lot of space.
Mm-hmm.
How it is possible in a house we can provide lot of space for this one?
See, this is one thing which can actually be planned. So if you have a backyard area or something like that, that can be planned. Now, especially if I talk of all these days, we have a multiplex housing and all those things. So in a housing complex, which is housing more than 150 houses or something, they can definitely have one facility wherein they are actually collecting all the grey water, treating it, and then using it for the lawn purposes and all those kind of things. So at larger scale, that can be done, and even at smaller scale with proper planning, these kind of things can be actually included. And if I talk of an oil and grease trap, it doesn't require a lot of space also.
Thank you, ma'am.
Okay.
Yoga, sir. Hello, ma'am.
Yes, please.
Ma'am, my question is, during sedimentation process of water, which chemical is used for breaking down of water molecules?
During which
And during sedimentation process of water?
Sedimentation process?
Sedimentation process of water, which chemical is used for breaking down of water molecules?
Sedimentation is just settling of the heavier particles actually.
Sedimentation treating of water जब करते तो उस टाइम में कौन सा chemical use करते हैं मैम? For breaking down of water molecules.
I'm not getting your question very well. Breaking down of water molecules, I didn't understand that.
Ma'am, which chemical is used at that time?
See, mostly there are for water treatment. If I talk of water treatment plants, that is basically an area of environmental engineering also. But there are things like fitkery and all; those are also very commonly used. Those alum is there, fitkery is there. These kind of things are used. They can also do the part for that. Even for hard waters, you know, calcium carbonates and all those carbonates have to be actually taken out. So those kind of chemicals are used wherein you form calcium carbonate out of it and all those things.
My second question is, which aggregate is best to use for purifying? Coarse aggregate or fine aggregate?
See, everything will have its own part to play depending on the type of waste that you're trying to remove from the water. So if it is very big particles, coarse aggregate will do the part. They will actually arrest all the waste inside it and water can flow. If you're talking of something very smaller particles, then finer aggregates will play a better role. So depending on the type of waste in the water, it has to be appropriately designed then.
Third, during curing of concrete, which water should be used? Pure water or impure water? If we use impure water, then what are the effects it on concrete?
See, again, for the curing of water, the standards that are required, so that have to be followed. So that doesn't necessarily have to be tap water. So impure water, again, of course, You don't want to unnecessarily introduce lot of chlorine or other kind of things. So that has to be, yes, taken care of. Chlorine will, of course, do lot of corrosion there. So I'm just giving an example. So you have to see, yes, you don't unnecessarily introduce some chemicals which will start reacting with concrete. So that has to be taken care of.
Thank you, ma'am.
Okay.
Thank you, ma'am.
All right. Any other center?
Good afternoon, ma'am.
Yes, yes, Bikaner.
This is Maharaja Krishan University.
Okay.
Yeah, ma'am, my question is, in industries, when we use aeration tanks,
okay,
we use blowers over there to ejaculate the water.
Mm-hmm.
Right, and but at that time, a lot of foul gases, foul smell emits from there. So, what can be done to reduce that smell so that the surrounding areas cannot be affected?
See, there are a lot of devices also that are coming these days. There are materials that can be actually installed around for the. This is actually that can be treated. This is a different type of treatment that will be required. So even, but again, we have to understand. Sometimes, first things first, we can understand that these things come at a cost. So even there is some foul smell. Yes, that can be a bit of a problem in that area. So for the foul smell and all, basically they can be actually, I would suggest there can be a lot of water plantations, tree plantations and all around. They actually do a very good effect around. They can be done. And other than that, even for those things, there can be a lot of, there are just like there are especially with the sprays and all those kind of things, there are chemicals which can actually absorb all these smells. So there can be some kind of foam kind of structures and all that can also be erected there. So that can also play the part there.
Excuse me, hello?
Yes, yes.
Can I know that how much amount of water can get treated by this method so that it can be, disposed of in soil?
What amount of water?
What percentage of water can be, treated with that? Treatment of, in how much amount it can get treated so that we can, says,
Okay, if I understand your question, you're saying how much amount of treatment is required so that before it can be safely put into the municipal waste?
Exactly, yes.
See, if I talk of this grey water, oil and grease is one parameter which should definitely be taken care of before doing it. And then things like food particles and all, they can be taken off so that they don't choke the pipes. So that can be done. If I talk of the black water, which is flushes and all, so that will actually require some good amount of treatment so that all the toxic things are taken out of it before as sludge. So they should all be collected as sludge before, so that all the toxic things are taken out before it is put into the rivers.
Thank you, ma'am. Thanks a lot.
Okay. Any other questions? No? Okay. Thank you so much, centers. We will gather back now again by 2:15 for the next session. Thank you.
हेलो म्यूट नहीं है, ओपन हो गया अब। यही खुद्दू बंदा गुप्ता दिया वो नहीं ओपन दिया।
स्टार्ट में है
अभी
requested to kindly get seated. We'll be starting in 5-10 minutes. Want to connect your laptop?
Yeah.
आपका कुछ पेन ड्राइव में है तो उसमें डाल एक्चुअली सबसे कनेक्टेड है
ये बनाता वीडियो है मतलब उसमें कोई साउंड तो चाहिए नहीं वीडियो तो वैसे चला जाएगा
कितना इसके साथ
our system were encrypted, we can't transfer any file from there. USB block.
laptops or USB block transmission.
Best copy of
हमारे सिस्टम
का है
40 MB 40 MB तो चला जाएगा 40 MB है GB
नहीं जीबी तो नहीं होगा 40 MB भी जाएगा नहीं जाएगा इसको ब्रेक करो दो पार्ट्स में एक ही टाइप करते
सेटिंग कर देते अपने वाले लैपटॉप सर्वर में यहाँ पे सेटिंग कर देते हैं क्योंकि वहाँ जो लैपटॉप रखे हैं
हाँ जी सर खुद को ही भेज लो एक बार यहाँ पे ओपन कर लेना या मैम आप मैं फिर से स्क्रीन पे भी कैमरा बट ये क्लियर कर देंगे बट क्लियर
Recently, they have blocked without informing us. They are connected in the network. तो उन्होंने ऑटोमेटिकली कर दिया
नहीं ऑडिबल है हेलो
Afternoon, all the centers. I hope everyone is ready at the centers. People, can we just see the centers once everyone is there? Okay. This is at this in Chandigarh University is there. Okay. Yes, everyone is ready. Bikaner and okay, Maulana. Okay, very good afternoon, everyone. We are now joined today by the team of Ultratech Cement, Aditya Birla Group, and we'll be today addressed by Engineer Gurdeep Singh, who is actually looking after the technical operations of the zone of specialty concrete of Ultratech Cements in the UP Ghaziabad area. He has a technical experience of more than 12 years, wherein he has been looking at the technical operations of this company in the NCR region also, and now he's in the UP area. With a technical background, he has done B Civil from Thapar Engineering College and provides the company is providing technical services in the area of value-added concrete. And I would like to add here that since we've been discussing since day one, all materials, they can go towards green also, and we've been emphasizing on that even concrete is getting green now. So this is one good opportunity we have with us, direct industry who are actually executing such projects. So without any further ado, I would request Engineer Gurdeep ji to kindly engage the session.
Good afternoon to all of you. Our today's topic is on the specialty concrete. What we can say, you might be aware of what concrete is. I think so. The basic of the concrete is the mixture of cement, sand, aggregates, and mixtures. It's a combination of all these things. Apart from these basic ingredients, we can add some other further more ingredients to have more value addition to our product. Like a concrete, we can value added it to another forms also. So on those lines, Ultratech is making some of the specialty concretes. I'm giving you some brief introduction on all those aspects, small points. First, I would like to give you an introduction of about our company. It's on the screen, ma'am. Oh, thank you. The Ultratech company is a part of Aditya Birla Group. We have already presence in 36 countries. As an ABG group, we have present in 36 countries, not as a Ultratech Cement. Ultratech Cement is one of the largest single brand in India. And we are a Ultratech Concrete, which is called an ready-mix concrete. We have almost around 100 RMC plants in all over India, which in 36 cities. And one of the major things is all our 95% of the plants are almost QCI certified plants. QCI is the Quality Council of India, which certifies the plants regarding to the Indian standards. So all our plants are certified from QCI. We are working as an industry in backward integration towards working on our own aggregate mines, so that the quality control and assurance of the material should be maintained. some of the concrete what we are giving it for various needs like residential, commercial, infrastructure, retail. And nowadays we are working for the micro retail. Micro retail is a very small quantities where somebody is looking for us for a, you can say, half a bag of cement concrete. If somebody is looking for a half a cement bag concrete, we can produce that and we can supply that to your cities also. So we are working on micro retails also. These are the major customers what we are working. These are the direct customers what we are working with. Now, what are the advantages of Ultratech concrete? Two advantages of Ultratech concrete is product advantage and service advantage. Where I could say elaborately, we have our own quality assurance system. We have one of the biggest, you can say it's a very stringent or a sophisticated system where we are monitoring all the database what we have, all the strength parameters, all the whatever we have, the fresh concrete database and hardened concrete database we are storing into our system, and they are generating all the material statistical analysis. They do material statistical analysis. We can design our mix design with this kind of a software. It's called a LabSys software. It's a Canadian software which is working with us. And apart from this, as a customer focus, because this industry is basically a service industry, we have to be very focused to our customer. So both of the systems, one is the quality control software called LabSys, is integrated with another software, is a SAP SAP, you might be understand. So both of the software are integrated, and we are working for dynamic order planning, scheduling, online mix design. All designs are being fed into one software and are connected to the servers. No batching plant computer can do any data editing in the system. Once the data is fed into a server, it is directly linked to any of the plants where we want to batch it. I give you a small pictorial. What is that? This is a quality test plan we do generally in all our plants. For every fine aggregate, we have to do each grade of each truck to be sieve analysis before accepting it, like silt content, moisture content, specific gravity. These are the following tests what we do regularly in our plants to maintain the quality assurance and control of the things. This is for internal tests for the fresh concrete and hardened concrete. We do various tests like slump test, workability, yield, and many other tests required as per the needs of the customers. This is a basic pictorial view of the RMC. You might have visited some RMC plants. No? So I give you a little brief on it. What is RMC? This is on left hand side, you see a raw material truck is being unloaded into a hopper. This sand or aggregate goes to a particular bins where all these bins are connected to a weighing system called load cells. Load cell can weight to an accuracy of 10 kg of the accuracy of the material for the sand and aggregate, in considering the sand and aggregates. Similarly, these two big silos, these are called silos cylindricals. They are containing cement, fly ash, or any other dry powder material which is being batched in that particular. All these ingredients are batched at an accuracy of 1 kg to 10 kg, depending upon what material you are going to use. And these are all batched through our load cell system, PLC based system. All the things are being batched and get into the mixers. And mixer takes almost 20 to 30 seconds to mix it and get it into discharge into the transit mixer, which is below that truck. Is you can see a yellow marked. It's called a transit mixer. So these all are being equipped with SAP system. Batching and scheduling is with batching Mixdesign is for Lapses software. All these softwares are interconnected to give you a better service and good assurance of the product. Apart from this, we have a technology in our transit mixers that is called VTS, Vehicle Tracking System. This vehicle tracking system is being designed for our system with our chronology of working. Like these are enabled with GPS. Whatever the truck goes to any sites, they are enabled with GPS system so that you can locate where your trucks is being going on. There are water addition sensors so that nobody should add water into the trucks to prevent any misuse of the water with the concrete. As you add more water, the concrete get deteriorated. So we have a control on water addition sensors. So whenever somebody adds water, it gives a alarm to our central monitoring system. They can check why it is being added. Then we have a drum rotation sensor. This drums works on a clockwise and anti-clockwise. Clockwise means you can take the material inside. Anti-clockwise, you can discharge the material outside the concrete. So we have a sensor over there so that monitoring the system. Other things are VMU. You can speak on the speaker phone. You don't have to pick any phone so that for the safety reasons. Odometer sensors for kilometers. These are some small technologies what we had added into these trucks for better serviceability. Now coming to a special concrete. Special concrete, as you know, after a water, most usage product as a commodity is right now is a concrete. Concrete is being widely used as a material for construction material. So specialty concrete is with a specially designed to achieve one or more properties like behavior, composition, and performance. What I could say, specialty concrete, normally a concrete, what we are looking for a grade of concrete, what grade it is being designed for, like M30, M40, M60 grades of concrete, or looking for workability. Apart from these property, 2 or 3 properties, what IS code says, we can design the concrete depending upon your needs, depending upon what structure you are going to pour it. Like if somebody is looking for a concrete which don't need a vibrations to compact it, so there's no specification key we can design those kinds of concrete which don't need any external vibration to compact the concrete. You understand what we are talking about? So there are n number of multiple possibilities for application. You can use it for multiple applications. Like if somebody is looking for a precast structures where a person is looking for a normal grade M40, but he needs a 1 day strength of 25 MPa. To attain 1 day 25 MPa strength, it's very tough task to design it. So we can design a concrete depending upon your needs, depending upon what user you are looking for. And that is called that's why we call it as a specialty concrete, because the basic requirements what you are looking for has been changed from what you are looking for. As we said, no two structures can be same, so any concrete which is being poured like M20 grade can't be used in any other structures. These 3 balls depict says, because every construction is a different ball game. You can't play a cricket ball with a golf ball. You can't play, right? For every game, you have to play with the different balls. Similarly, for every construction application, you have to design a concrete according to that requirements. So what those requirements are, some of the specialty concrete what we have a portfolio is 13, 14 I brought up for your understanding. These are like Thermocon. These are our brand names called Thermocon, Decor, Scuracon, Hypercon, Colorcon, Lightcon, Free Flow, Pervious. I'm going to give you small introduction about all these concrete, what they are going to give it to you, what value addition you can have from them. like thermocone. Thermocone is a temperature controlled concrete for a mass concreting purposes for a critical jobs. Nowadays, you have seen there are multi-story buildings being constructed in all over the India. So while constructing these buildings, we have to cast a big rafts of almost around 2.5 meter or 3 meter deep rafts. We have to design it. While designing those kinds of concrete, we found there's a when we place a concrete into any of the structure, the concrete get hydrated. You understand what is the hydration? When cement get reacted with water, it get hydrated and it creates an exothermic reaction. Those exothermic reaction, when we cast a big raft of almost 1 meter or beyond that 1 meter, so that the temperature of that raft, suppose this is a big raft, this hall is a big raft, you can see the center CG is lying where this camera is here, so that the temperature at that point might be around 70 to 80 degrees Celsius of that concrete. So what does it mean to you? That temperature is no point to monitor. Why we need to control that temperature is because there is a difference between the core temperature and the surface temperature is beyond 20 degrees Celsius. If you had placed a concrete in summer weathers, so the ambient temperature is almost 40-45 degrees Celsius, but the core temperature is almost 80 degrees Celsius. So the difference between the core and the surface is almost 35 to 40 degrees Celsius. So studies says when these differential in temperature is beyond 19 degrees Celsius, there are various micro cracks created in the concrete structure, which is not good for the health of the structure. For making it a durable concrete, we have to reduce the differential. So to create those kinds of, to maintain the core temperature so that the difference should not be 19 degree beyond, we have to use some special design mix, and we have to use some special materials to produce those kinds of concrete. So in those consents, we have to design various concretes. You have seen there are many big structures are being casted, like metro or big rafts for big foundations. The grade of concrete could be anything like M25, M30, M40, but the value what we are looking for is the controlling the core temperature of the mass concrete. So this is the value addition what we are doing into the concrete design. The grade of concrete would remain the same. These are some of the projects what we did. We had monitored the core temperature. You can see there is a graph lying here, red and green, red and blue. So it says the core temperature difference between the surface temperature. We can monitor these temperatures also in your raft. Now, other product is called Hypercon. Hypercon is basically a high strength concrete which is beyond M60 grade of concrete. Why we need a M60 or M90 grade of concrete or M100 grade of concrete? Generally, a building of 35 or 40 story building, if we construct, we generally use a M40 grade of concrete, which have a column size of this much of size of M40 grade of column size. So while designing the concrete, we can design the M40, we can change the design from M40 to M70 or M80 grade of concrete, the size of the member also of the column. M40 we designed concrete with this much of size. If we change the grade, we can design M70 or M80 with this much of size. What did you get? You get the extra area, floor area, working area. Suppose this is a column. This is a bigger size of 1 meter by 1 meter. If you reduce this column size to 600 by 600 and change the grade, what did you get? You get the extra space. The space is a value today. Apart from this, you had reduced the dead load of the total structure. You have reduced the dead load. So you can change the grade of concrete from M40 to M70 or M80 grade of concrete depending on what design values you are looking for. Apart from this, what you have extra is a long-term durability. We can, these concretes are being designed for low RCPT's values beyond 1000 coulombs. So you will get a higher sustainable concrete which will last for longer time period. You understand? Some of the projects what we are doing right now, we are doing up to M95 grade of concrete in Mumbai. We supplied M90 grade in Gurgaon, M80 grade in Gurgaon. I think highest grade in Punjab we sold M60 grade of concrete in Punjab. Some of the projects what we did, we achieved almost 112 MPa strength in M80 grade of concrete. This slide is not on. This is some of the buildings what we did. Coming to another topic called free flow. Free flow is a self-compacting concrete which don't require any external vibration. You might have heard about this concrete. You have heard? So this is a concrete which is designed for today's needs, where workmanship is one of the major challenge, where we are lack of good manpower for workmanship areas. So this concrete is being firstly designed in Japan. Excuse me. Japan. Why they designed it? Because in Japan they are having a lot of problem of a good manpower who can work at the site, who can compact the concrete at the site. They are finding those problems. So while those challenges are made this concrete to come into the picture. So this have benefits. You can use it for very congested reinforcement areas. You can, where you are looking for a very superior high quality finish, you can use it in the structures. It have a better degree of compaction and being a better impermeable and durable concrete. Sorry, I have a video on this, but I can't play right now. Some of the projects what we are doing, there are many projects what we had not shown over here. Very small locations. Now people are converting their small even houses, they are converting to a self-compacting concrete, because they had designed some kinds of architectural detailing into the concrete. They have to only to use this concrete only. Otherwise, if normal concrete is being poured, you can have a blowholes or honeycombing in any of the structures. So you can reduce the labor cost wastage or repair cost. You can reduce those costs also. This is a fiber reinforced concrete. This is being introduced by adding some fibers into the concrete. It's the same technology what we been used, like मिट्टी के अंदर वो भूसा डाल के करते थे to prevent the shrinkage cracks of that mud. Same is being concept is being revised into a concrete, where you can use polypropylene or polyester fiber into the concrete so that shrinkage can be reduced. And there are many other fibers like steel fibers which can be used to make the concrete from brittle nature to a toughened concrete. You have seen a normal glass. A normal glass is a brittle in nature. A similar glass is being converted to a toughened glass for a windscreen purposes. So it will have a better properties, like it have the nature has been changed from brittle to toughened. Similarly, a concrete which have a fiber reinforced concrete in steel fiber is being used. So you can change the properties from a brittle nature to a toughened glass. toughened concrete. So you can have improved crack resistance where very high wheel loads are there. For industrial flooring, this kind of concrete can save a lot for you. You can save your project cost by almost 5 to 8% in your project cost by replacing the normal steel with this fibers. We are doing a lot of concrete in India. Almost in 3 years, we produces 18 lakh square feet of area in India. Some of the major work what we did with Walmart over here in your Baddi area, Zirakpur, sorry. Duracon. It's a next topic called Duracon. It's on a high performance concrete. This concrete is designed specifically where you might have seen when we are constructing a building of 5-story or 6-story building, we design the concrete for 28 days strength. Generally, we design the concrete for 28 days strength. That is as per the Indian standard. But in our case, what we are saying, if the concrete load is going to come after a 1 year, if you have to construct a 4-5-story building, why we are designing a concrete for 28 days strength? Why can't we design it for later age strength? The service load is going to come after a year, so why we are designing the concrete for 28 days strength, right? So for that purpose, we can design a concrete for 90 days or 1 year or 3 months. Concrete strength achieved, the same grade can be achieved in 3 months. Why we are looking for 28 days? We are wasting our energies to getting the 28 days strength, but the service load is going to come after a year. So we can optimize our mixes, we can reduce the cement contents in those cases so that we can design the later age strength. So this is a concept what we are using. We are doing a lot of concrete, this kind of concrete also in India. Now consultants and architects are accepting this things. Even owners are now accepting why we want to waste concrete. If somebody is designing with 400 kg of cement and some part of fly ash, a same concrete, if we can design it with lesser amount of cement and higher amount of other materials, we can design it. So these are some value addition for many of the purposes. This is some of the project what we did. Almost we do a lakh of cubic meter in India with this kind of a concrete. Major rafts are being done with this kind of concrete. Some of the results we are showing, currently our Indian standard is not making any changes for accepting these kinds of changes of 28 days to 90 days. So but ACI is giving that you can, wherever the mass concreting is there, you can change the strength age from 28 days to 90 days also, or even up to 1 year also. So some of the test results you can see niche below, there is a graph. You can see a conventional concrete of M30 grade and red is a Duracon. You can see this is crossing to a certain extent at 90 days of age. This is crossing to a conventional concrete. The same grade is crossing the normal concrete strength. This is architectural, another way of producing the concrete. This is a concrete which is being laid at site and been imprinted on the site. These are not tiles. These are the concrete which is being laid freshly, are being broadcasted with some colors in the fresh state and been imprinted at the site. So you can have n number of colors variations, n number of textures, n number of design. You can create your own. This is beauty for the architects. You can replace your existing shabby floors with this kind of concrete. Some of the things what we did. This is a lightweight concrete. Lightweight concrete is a concrete which have a density lower than the normal concrete. Normal concrete have a density of around 2400 kg per m cube. So this concrete gives you a density of almost 800 to 1000 kg. So it is a lighter than water. Even it can float on your water. So this is being used basically for heat insulation purposes or for filling purposes. You can replace some soil with this kind of a concrete. You can reduce your dead load of the structure. So it can be used for green building concept also. People are using this as a green building material. So you can reduce your dead load of the structure. But one point is that they are not capable to take any load. They can use as a filling material. You can't design this particular what we are talking about. This is not designed for any grade of concrete. They have a very low values of strength, around 1 to 2 MPa strength only. But we are working with other structural lightweight concrete which have a strength of 18 to 20 MPa, which can be designed. But we are working over here with different kind of aggregates. Some of the projects what we did, Bangalore, Punjab, everywhere we are doing small quantities. This can be used for toilet sunken filling areas, or you can use it at a roof or for heat insulation purposes. This is another concrete being value added as a high performance concrete called Ultratech Plus. This is being designed for a very high slump retentions. In the RMC, we have a very big challenge to retain the concrete from one side to other site. If a site is at almost at 4-hour traveling time, so we have to design the concrete so that it should retain the slump workability and the strength parameters. To design those kinds of concrete, we need some special additives. We are using it. And in many of the cases, if we have to pump a concrete around 300 meters a height, so it would be a very challenge for us. So we have to design the concrete according to those parameters. It's a colored concrete where you can change the shades of the concrete from gray to color. It's also the colors what we use are UV resistant color, and you can use it for exposed concrete surfaces. It can be used for driveways, patios, swimming pools, anywhere. One project what we did in Jaipur is a hotel Fairmount. They want a color of the roof is same as the color of the stone what they used. Below is the picture where we have to match the color of the stone with the color of the concrete. Some small works also we did in Gurgaon also. This is for precasting boundary walls. They want a precast boundary walls of colored concrete, which can be lifted day after. So these small things what we are doing as a value addition, which can gives a value to customer and to the society also. This is a pervious concrete for green building purpose. This concrete is a reversal of normal concrete. It's a pervious concrete where you can drain any water to underneath. You can recharge your water table like rainwater. It can be used for rainwater harvesting purposes. So a concrete is being laid on the subgrade soil. So whatever the rain goes directly into the soil. So you can use it as a rainwater harvesting purpose as a green building concept. But currently not much volume we did, small quantities we did here and there, not in big quantities. You can have a variation. I taken a pictures from other countries. You can change the colors, you can change the variants. There are multiple possibilities you can, depending on what you are looking for. This is a right now we had designed a product called AquaSeal. It's a waterproof concrete. It's another product where you can change a nature of hydrophobic concrete to a hydrophilic type kind of a concrete. Hydrophilic means if you put a water on this table, it will not get seep into the material. So this is a kind of a concrete where whatever the water is there, did not get penetrated into the structures. So we are designing these kinds of concrete also for water retaining, like swimming pools or big water tanks or even roof slabs also. Some of the comparative between this kind of that thing. This is a zip concrete. What I am telling you about, this is a micro retail concrete project. We designed a concrete which is being supplied in these small buckets of paint buckets, like you can see in that picture. This bucket is almost around 30 kg bucket weight, and you can ask for any kind of for repairing purposes. If somebody want to repair a small patch hole in their roof house, so they can call us. We can supply you 2 or 3 buckets also at your site. So this is a new service for the customers. Generally, normally if we have to buy a cement, it costs around 300 bags of a cement. So part of the cement get wasted because you are going to use a half of the bag, and half of the bag will get wasted. So in this case, you can call 1 or 2 buckets. We can supply it to your site, and you can pour it and finish it off at your ease. It's a do it yourself kind of concept. You don't have to mix it. You just open the lid and pour it and finish it off. We can even design this kind of a concrete for your special needs. This is the first project what we did in India. We supplied a zip concrete for this part to be repaired. This is a corrugation factory floor which generally get deteriorated by multiple usages. So the customer is looking for a very small quantities, and they want the concrete should not be deteriorated by the time in 1 or 2 years. So we designed this special concrete with the steel fiber, and we said this will last for many years, not for 1 or 2 years. So this small quantity is being produced with a zip. This is another case called Rapid. Rapid is for the repair purposes. We are designing a concrete where you can use your floor area after repair in 24 hours. This forklift is being used after repairing the floor after 12 hours. You can use this kind of forklifts also on that floor. So the concrete can be designed for 12 hours strength of 40 MPa also. This is a customer needs. He wants the floor to be opened within 12 hours after a repair because they can't shut down their factory work. So we design this kind of a concrete where you can achieve a 40 MPa strength in 12 hours. So there are multiple applications you can use for highways, road repairs, bridge decks, parking areas, industrial floors. What benefit you get? The benefit you get is the time. The value you get is the time. M40 grade, you have to cure it for 7 days minimum to get the strength. But in our case, we had designed a concrete which you can use it after 8 hours. So what you get the value? Understand? So value of the product, like if we want to travel from here to Mumbai, we can travel it by either of the ways, like we can use by air, we can use by a train, we can drive it. So depend upon what value you're looking for. If you want to, but the cost is there. If you want to drive, the value is there. If you want to go Mumbai by air, the value is there. So that is the difference then. This is another called corrosion resistant concrete called stainless concrete, where water is very alkaline in nature, or some industries where concrete is being used at very aggressive environments like acidic environments. So we can design a concrete for so that steel should not get corroded by the time. So this is another concrete. It's almost last slide for you. This is some of the work what we did. In Ludhiana, there is an factory which make honey. Honey is an acidic in nature, so it changes the concrete. So we designed the concrete so that the concrete should not get deteriorated. Apart from this, we are designing a high density concrete where somebody is looking for a radiation shielding purposes, like X-ray, gamma rays are there. So we are designing those kinds of concrete also. So this is up to you. Thank you for this session. Any questions? Or it's all over to your.
Thank you, Engineer Gurdeep ji. That was a very informative session, and I think especially for the students, the types of concretes that are available, and actually by using these type of concretes, the amount of cement and all has been reduced, the time is reduced, so it is all leading to greener material. So centers, do you have any questions for the expert?
Yes, ma'am. I'm Gurnath Prasad again, ma'am.
Yes, please.
Yeah, ma'am, I have a question about the buildings, ma'am, the construction of the building. Construction of building. Actually, you know, if we will have to construct the towers that have more and more height, just like World Trade Center. World Trade Center. A question struck in my mind that if you have to construct a building which is having high height, long height, so it is required to make it with steel structures. Yes, ma'am. Ma'am, are you listening?
Yes, we are, but it is not necessary anyways. Steel is one of the option. I'm not sure what your question is. Steel, yes, can be used.
Yeah, steel is required to make it less weighty. Means it has less weight. If we will use this steel, if we will use the concrete.
Okay.
If we will use the concrete, so it will be having increasing amount of weight will develop in that building. So it is not possible to construct a building with cement which is having high large length. So due to catastrophic conditions in high thermal conditions, just like in 9/11 attack, have you heard that occurred in WTC center? So is there any remedies that you have? Is there any remedies for the building which would avoid that type of attack because in case of high temperature conditions, the structure will collapse, and so if we will,
Right. First
so
of
if we,
all, the example that I've given, the World Trade Center. So actually, if you see the way it failed, that was a engineering marvel in itself, I would say. The building, if you would notice, it did not explode; it imploded. So all the catastrophic that happened, that was within that site. So there were not particles flying around. So that was, the building was quite well engineered. And regarding your question, yes, steel structures are lighter, but concrete can also be used for high-rise buildings. So that options are always there. Yes, they are there. It's not necessary, although yes, you have to make a choice as an engineer when you're designing which type of structure you go for, steel or concrete. And for steel, as far as is concerned, steel can be fire resistant also. And steel can be made to actually withstand high temperatures also. So those kinds of treatments are also available for steel. It's not that steel is vulnerable to fire or corrosion and all those things. So there are steel structures which are very good engineering marvels which are there. And either ways, materials can be used with proper designing and construction.
yes, ma'am. Actually, I have the question just got struck in my mind about. Actually, I have saw a documentary about the 9/11 attack, and there was some demerit of that building because the high thermal radiations, when this the plane get into the building, it just a tremendous amount of energy liberated, and just
Yes,
gets
that was actually a very high amount of event. That is like when you talk of limit states. So that was
Yes.
kind of a state that is not anticipated to occur very often. So if we anyways, that was an event that occurred, and now actually the buildings are being designed for accidental loads also to
Yes,
account
ma'am.
for things like this. So we have my expert who would like to add on here.
Okay, ma'am. Thank you.
As per your question, right now we are working on a concrete that will be more prone to these terrorist attacks or any explosive attacks. We are working on that. We are right now we are supplying concrete also to our defense, where they're working, and the concrete is not a very unknown. It is a fiber reinforced concrete, and till M50 concrete, our concrete is being tested for the nuclear tests also. And right now in the Chandigarh, there is a TBRL lab where we are supplying concrete for these nuclear tests also. So for any accidental or any attack like terrorist attack like situations, the concrete may be able to sustain that attacks. There's a R&D already going on that. The fiber reinforced concrete. This answer.
Hello, ma'am.
Yes.
Hello, ma'am.
Yes.
Hello, ma'am. This is Sakshi from Maharaja Agrasen University.
Yes.
Ma'am, my question is, you talked about the colored concrete. So I just want to ask you, using the color pigments in concrete, does it gonna affect the overall workability and the strength properties of concrete?
No. All those strength parameters are retained. There's no effect on the workability. They are taken care very well. And the strength is also retained. Any grade of concrete or any workability required with the colored concrete will be fulfilled. There's no problem with that.
Okay, thank you, sir.
Afternoon, ma'am. Good afternoon. Good afternoon, ma'am.
Continue with the question, please.
Ma'am, my question is about Ultratech Rapid cement. What is the mechanism behind the Ultratech Rapid cement that we are getting the strength of 35 MPa or 50 MPa within 8 hours or 12 hours? The strength which we should got in 7 days or 14 days, we are getting it within 7 hours. What is the mechanism behind it?
Yeah. Actually, these products are mostly patented products, and we cannot disclose the secrets. The only hint we can give is that we are using a very good, very high class accelerators to produce that concrete.
Sir, but I want to know what is the accelerator which makes it so highly strength within 8 hours or 12 hours? Sir, can I know the name?
Yeah.
Sir, not audible.
They are pure silica we are using. So there are many fillers what we are using called micro or nano fillers, which are increasing the efficiency beyond the cement. As if we can say cement have an efficiency of a strength 1, so those kinds of micro filler have a efficiency beyond 30. You can say a ratio of 1:30. So those kinds of fillers are being added into this concrete. Apart from the accelerators, are widely available in mixture industry. We had selected some of the accelerators to attain those strengths. That's
Sir, with accelerators, we are adding the fillers.
yeah. There are cementitious filler, I can say.
Sir, can you name some of these fillers?
Yeah, definitely. You have heard about microsilica or alcofine?
Yes, sir.
So those kinds of fillers are there.
So that means if we are going to, in how much range we are going to add in it concrete? What is the
Sorry?
range we are? What is the range and what is the percentage?
You want to make a concrete with that?
Yes, sir, but I want to know what is the percentage we should add in concrete such that we can get the strength within 8 hours or 12 hours.
So I can share it you, but we can't share it right now in this studio. I can share it with you. Please let me know. My contact number is 9718991183.
Sorry, sir, again.
9718. It's on the screen.
Sir, not visible.
They are from Chandigarh. Any other questions?
Okay.
So first, and I can remedy is the water. What water you are using for the purpose is not fit for your purpose. You have to. So you have to. Yeah. Okay.
After how many times? How many days?
After 2 or 3 months.
Okay. So those are efflorescence patches, generally which comes around 2 to 3 months within a time period. So those are because of the alkalinity of within the sand or within water you are using. So we have to make sure that whatever the materials we are using, it should be free from those kind of things.
Now what to do before
After that, it's my way. It could be a vague idea, but I am not into it right now. So might be you have to look for some other kind of a sealer which can use on that surface. Might be.
Usually,
I'm not-
fluorescence usually comes on the
Dampen area.
portions. You have to stop that dampness. Usually, the fluorescence comes from the brickwork, not from the concrete, and the soil used for the brickwork is not fit to be used. So there is a lot of alkalinity in that, and while making those bricks, while burning those bricks, the brick kiln owner are using salt also to make a catalyst for lowering the melting temperature of the bricks, and that salt comes out of after a certain period of time.
Other white patches are there called leaching, which comes way back after that is because of the so to prevent those kinds of happening, you have to use mineral mixtures like fly ash or silicone. It should not get out.
Make again cement.
Is it audible?
Yes.
Yes, audible. I'm from MMU Milana. Okay. And my question is that on one side we are talking about sustainable construction and we are going to reduce the level of carbon being produced because of cement. And on the other side we are talking about a number of various concretes in which a lot of cement is being used. So how will it affect the sustainable construction? Can you justify the use of these kind of concretes for sustainable construction?
I have got the actually the basic concept for our value-added concrete is to cut the uses of OPC cement, because almost 10% of the carbon dioxide produced is through OPC manufacturing, through the cement industry, and all our value-added products are designed in such a way that we are reducing the uses of OPC cement and we are replacing other materials, and that too green in nature, to replace the OPC cement and increase the properties and increase the various aspects of concrete in uses point of view also. So actually we are not increasing the cement content but decreasing by making value-added concrete and replacing with other greener products.
And the composition features that, like if I talk about one particular, say, unleached cement, concrete, that is what will be the percentage of OPC if it is not the normal concrete, as compared to the normal concrete, what percentage of cement will be reduced in this?
It is different for different products. Like in Duracon, we are replacing at least 50% of the cement with fly ash and other mineral mixture also. And for making hypercon concrete, we are replacing the OPC cement with silica. That is also, and even with the slag also. That is a byproduct of steel industry. And that is we are replacing in South India by almost 70% with the OPC. For sustainability, apart from, as you have seen, there are a lot of challenges to bring a natural sand of or other kind of a sand. So now the industry has looking for alternate to the replacement of the sand. Like people are using sand or mound ash as a filler material to replace the sand percentage, partial replacement of the sand also. Now you can use a slag, coarse slag to replace the aggregates. So for sustainability, we are looking for various alternative so that whatever there is a bioproduct in any of the industry, we are working with those kinds of materials also. Apart from the cement, we are working with other bioproducts which is can be used to stop the degradation of sand or natural resources.
Thank you. In fact, I would like to share that we are also working in one of the first areas for improvisation of concrete for making sustainable construction.
Yeah.
And maybe in future we will be using your know-how to increase the research. Thank you.
Okay. All right. From here. Is that interesting? Yeah, please.
For the purpose of learning.
Yeah.
So we do research on material science. As you mentioned, we couple all those fibers, natural and synthetic fibers with the materials, and we fabricate the component. That is only for academic purpose. Few of my PhD scholars are working on it. And similar way, we mixing a nano size particle with that of the aluminum and copper and other alloys, and we make some kind of all for academic purpose. We write thesis, we submit paper, it's all available, and we have also patented 2 or 3 matters like that. But whatever you mentioned is reflecting on business. So we would like to know what percentage of impact is added because of having a kind of, you mentioned that the value is added. I mean, in one term, the size is reduced, you have enormous space. Earlier it was more space occupied, now it has a lesser space. So similar way, you added kind of nanoparticle, and it adds strength and immediate cure, and curing time is reduced, size of the beam is reduced in all that way. When you add one particular value, have you made any analysis? See, one particular kind of value addition added this much percentage of impact on the business strategy. In that way, do you have any analysis like that? I have asked because you people are extremely expertise. You reflected on business. Whatever you've done, your innovation reflected on business in terms of crores of money. But we do only for academic purpose. I post this question only to know and educate our people. Please come.
Thank you. Thank you. It's a very interesting and good question. Currently, I don't have any figures right now because we didn't did analysis on one particular job. We had some of the studies with like self-compacting concrete and other concretes also, where you can reduce what value addition the person is getting. So we have some of the analysis with some of the products, not with the every product, but it's a keen interest. We can work on hypercon. We are looking for these kinds of ventures where we can jointly work with any of the institute or any consultant. We can work together to understand what value addition in the structures can be done by reducing the columns widths or beams. So we are open to it, and we can work jointly if you are interested in that. Yeah. Yeah, definitely.
So when you bring some innovation, in another way,
Definitely. Uh, Again, it's a good. Uh, Definitely, there are a lot of challenges, and there is more of competition going on. Why the company has get into this value-added concrete? The first answer is because we want to be differentiated from the competitors. That's why we get into this value-added concrete for the customer needs. So as a company, we have to be ahead of it. So we are tremendously working on new innovations and customer needs. We have one R&D center in Mumbai, so all the team is working there hardly for designing and innovating products. uh, Another question is that the company, sorry, I skipped that last question you said. It's yeah, sorry. The standards we are we have to be with the Indian standard or American standard, whatever the standards we are have to follow those standards. But apart from these standards, we also had benchmarked our own standards to maintain the quality assurance. Many of the cases, the standards are a bit vague or bit wide to make those assurance purposes. So we had narrowed down those standards to our limit so that we can make those um, make those assurance to be more stringent for our purposes to maintain ahead of the competition. So we have some part where we are following our own standards apart from the Indian or American standards. Yeah. One thing I can assure you, the parallel work is also going on with the branded companies, within the branding companies, and we do share with their work with our work. And yes, we have made so many value-added products, and we have named in a differently, and other companies have named the same product in a different way. They have the products, and uh, although there is no benchmark for uh, Indians have not standardized these evaluated products, but a parallel work is also going by the branded companies.
We
final
get
draft is ready.
final draft is under process, so we are working them jointly so that good methodology of designing a different kind of concrete is to be come into a picture very soon. We are covering there chapters like self-compacting concrete, mass concreting.
It will also be
So some of the chapters are being added into the Indian standard also. So our team is working with the Indian standard also. Which course, sir? So cost is cost. I don't know what would be the impact, but it would be a information for everyone who want to design at any city. They can design it. So we are now working because it will help us to market this product more efficiently and more easily in government bodies, but because some government bodies are very stringent to the Indian standard norms. So if the Indian standard cover these kinds of products, so we are easy to get into the things. So as commercially we more get into the things, the cost would get automatically reduced by the time. Currently, it is
If
on
we go
higher
with
side.
commercial analysis, especially for the this self-compacting concrete.
Yeah, it has been reduced.
The cost will be reduced because overall there will be reduction in the manpower and there will be saving in the energy also. From the sustainability point of view, after all, our goal is to cut the energy uses. And if we are using self-compacting concrete, you don't need to require energy to compact the concrete. You don't need labor to spread the concrete. It will be pouring just like pouring a water and automatically filling the formwork. So yeah, yes, yeah. And then there will be saving also. Overall saving the product cost of product is little more, but overall saving will be there.
Customer expectations are based on the competitors with your product or by your own. While how you have developed types of specialty companies. So one is based on ice cream, one is based on green flow, whether by your own, by understanding the other problem. Yes, these are designed. These are most of the things are designed depending on the need, and sometimes customer is not aware what their needs are. So we have to understand the needs before going into the thing. We design some of the products which are being designed by our innovation, and we can change the needs that we are looking for. So it's a combination of the things. So there are many ways.
We are exploring the possibilities.
Innovation is Thank you. Thank you very much. Thank you. We are really happy to have such a wonderful experts here. At this juncture, I would like to thank our organizer. Thank you.
I will just add to what was being discussed. I think one application of fiber reinforced concrete is in the seismic areas because of its increased ductility, toughness, and it has a very improved tensile strength. Otherwise, concrete is known to have tensile strength of hardly 10% as compared to compressive. But with these fiber reinforced concrete, you can play around with the fiber length, aspect ratio, the volume, and the way you place them, even the angle orientations. So you can go up to like any kind of toughness and ductility, fracture toughness. All those things can go up to vary, and there is a lot of research which is going on in this area. So they are being very nicely actually being fiber reinforced concrete is being used in seismic areas to a very good extent. Even yes, and actually with this fiber reinforced concrete, the conventional rebars can also be replaced. So even with fiber reinforced concrete, the conventional rebars can be replaced. So a lot of reinforcement congestion. Yes. Composites, yes. See, actually, it is a composite only between steel and concrete and all those things. So cement and everything. So it is a composite. Okay. So we can check again. Anyone else has a question in the centers? Okay. Maulana ka to kuch. All right. So I think this is a good junction. We'll close for the day today, and thank you for the session today. So tomorrow we'll all assemble at 9:30 again for the session on alternate energy sources. Thank you, centers. Have a good evening.